Hello there and welcome back to the Sleep Science. You're standing at the edge of something so massive that even light itself can't escape. Around you, space hums like a deep, cosmic engine, and time feels thick, syrupy, stretched beyond comfort. This isn't a dream. Well, not exactly. It's the event horizon of a black hole, that strange region where physics begins to whisper secrets it never meant to share. You probably won't survive this, but that's sort of the point. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Go ahead and drop your location and local time in the comments. There's something soothing about realizing you're falling through the universe together, even if it's 3 AM in your corner of it. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The darkness in front of you isn't just empty space, it's a boundary. A place where space-time itself collapses inward, pulling everything, even photons, into an invisible whirlpool. You hover near it, the way an insect might hover over the edge of a hurricane, caught between curiosity and common sense. Behind you, the faint glow of distant stars bends strangely, light curving around the gravity well like ribbons of molten glass. It's funny, really. Humanity once thought the cosmos was serene, eternal, clockwork. Then came Einstein, tossing a wrench made of geometry into Newton's tidy machinery. Space wasn't just a backdrop anymore, it was flexible, stretchable, moody. And gravity wasn't a force, it was a conversation between matter and curvature. Put enough mass in one place, and space-time caves in like soft bread under a spoon. Voila, a black hole. You take a slow breath, though to be honest, your lungs wouldn't survive the radiation or vacuum out here, and feel that peculiar sense of vertigo that comes from knowing your next step isn't down but inward. Astronomers have spotted these things lurking everywhere, from stellar corpses a few kilometers wide to supermassive behemoths, billions of times heavier than the sun. Each one hides an invisible boundary, the event horizon, that unites terror and elegance in perfect measure. Historically, the idea began as a kind of mathematical joke. Back in 1916, Carl Schwarzschild solved Einstein's equations while serving on the Eastern Front in World War I, because apparently artillery shells weren't enough excitement. His solution described how space-time behaves around a dense point of mass. He didn't call it a black hole, he just wrote about a singularity, a place where the equations broke. No one thought it was real, not then. You watch as a small star ventures too close to the black hole's edge. It elongates, stretches like molten taffy, and shreds into an incandescent arc. Astronomers call this spaghettification, which sounds adorable until you realize it's what would happen to you. But right now you're weightless, just an observer, safe in the way dreams make you safe. You can feel the gravitational field tugging not just on your body, but on time itself. Seconds near the event horizon dilate, slowing until an outside observer would see you freeze forever. Yet for you, everything continues smoothly, calmly, almost peacefully. That's one of the paradoxes of black holes. They break intuition while following the rules. If you were to drop a clock into 1, it would appear to stop as it reached the event horizon. But in your own frame of reference, it ticks along normally until it doesn't. Historians still argue whether the concept of time freezing there is just a coordinate illusion or a genuine physical phenomenon. Einstein might have smirked and said, both. There's another oddity, a quieter one. Black holes aren't truly black. If you could see across the electromagnetic spectrum, you'd notice fierce jets erupting from their poles, powered by magnetic fields and in falling matter. Some of these jets shoot across thousands of light years, as if the whole is screaming its existence into the void. And yet, right at the center, silence. Perfect, cold silence. It's in that silence that the strange rumors start. Maybe, some whisper, black holes aren't endings at all. Maybe they're portals, exits, cosmic wormholes disguised as death. You glance at the smooth, unseeable surface before you and feel that quiet thrill, the same one sailors must have felt staring at the edge of the world, wondering what dragons waited beyond. Speaking of dragons, medieval scholars once thought the stars were tiny holes poked in a celestial sphere, letting heaven's light leak through. In a delicious reversal, black holes are like anti-stars, holes where light falls in and never leaks back out, a cosmic sink instead of a window. Still, Both speak of curiosity, of peeking behind the curtain. You drift closer, your motion accelerating despite every instinct screaming to pull away. The horizon glows faintly in X-rays as infalling gas heats to millions of degrees. Somewhere inside, perhaps, space-time folds over itself, one continuous surface meeting another. Mathematicians can describe this elegantly, like origami done in 4 dimensions, but describing isn't the same as understanding. A random thought bubbles up. Could someone on the inside see you out here? Some theories say no. Crossing the horizon severs communication forever. Others argue subtle quantum effects might still transmit whispers of information, maybe through entangled particles straddling both sides. The debate is fierce, unresolved, and beautifully human. You notice, with a small laugh, that your reflection, if you could call it that, doesn't behave normally. Light bending around the hole paints a ring, a luminous halo that looks suspiciously like the first photograph the Event Horizon Telescope captured in 2019. Humanity's first portrait of the unseeable. There it was, glowing at the heart of Galaxy M87, 55 million light-years away, its gravity distorting reality itself into art. Out here, surrounded by cosmic silence and slow time, you feel something unexpected. Calm. The fear ebbs into awe. The pull of the black hole isn't just gravitational, it's philosophical. Every culture, every person, every mind asks the same quiet question. What happens when you reach the end? And if the end isn't the end? You hover there, on the razor edge between curiosity and oblivion, knowing that the next step will take you past where physics feels comfortable, into something we still barely name. The horizon trembles in front of you like a mirage. Maybe it's a mirror, maybe it's a door, maybe, just maybe, it's an exit. You fall, not in panic, but in that slow, syrupy way dreams make gravity optional. The pull is gentle at first, then increasingly persuasive, until even your thoughts begin to curve inward. As the event horizon swells in your view, you can almost hear the hum of history, the long, improbable tale of how humanity even found out such monsters could exist. It's easy to forget that black holes began as a curiosity, not a certainty. Back in the late 18th century, long before Einstein's equations rewrote the cosmos, a few audacious minds had already imagined something very much like them. John Michell, an English natural philosopher with the patience of a saint and the charisma of a damp scorn, calculated that a star 10 times the sun's mass, but compressed into the same diameter, might have an escape velocity greater than light. He called it a dark star. His colleague Pierre-Simon Laplace agreed, until the 19th century arrived with its shiny new wave theory of light, and politely erased the idea. You glide through the centuries as if they're pages turning around you, starlight flickering between the folds of time. In the early 1900s, physics was in crisis. Newton's clockwork universe had cracks. Mercury's orbit misbehaved. Light bent around the sun, though it wasn't supposed to. Into that chaos stepped a young patent clerk named Albert Einstein, who in 1915 presented his general theory of relativity, a mathematical love letter to space-time itself. Gravity, he said, wasn't an invisible tug but a ripple in the geometry of existence. You hover near that thought for a moment, admiring how elegant it sounds until you try to actually calculate it. The equations were beautiful but cruelly difficult, non-linear, temperamental. Then, astonishingly, Karl Schwarzschild found a perfect solution while calculating from the muddy trenches of World War I. Imagine it, artillery shells whistling overhead, and this German physicist scribbling equations that describe the exact curvature of space-time around a spherical mass. That's dedication, or escapism. Schwarzschild's result predicted a peculiar boundary, a radius where the math exploded. Later physicists would call it the Schwarzschild radius, now synonymous with a black hole's event horizon. He died of an illness just months later, never realizing his work had birthed one of the most haunting ideas in science. You picture that solution as a kind of ghost in the math, silent, exact, but unnerving. Einstein himself didn't buy it. He thought nature would never allow such absurd infinities. For decades, the concept lay dormant, a theoretical oddity whispered about in lecture halls but dismissed in polite company. Historians still argue whether Einstein rejected black holes out of intuition, ego, or the simple fact that he disliked untidy infinities. Whatever the reason, he missed the cosmic memo. The universe loves untidy infinities. Fast forward to the 1930s, J. Robert Oppenheimer, yes, that Oppenheimer, turns his sharp intellect toward collapsing stars. Along with his student Hartland Snyder, he calculates that when a massive star exhausts its fuel, its gravity can overcome all known pressures and collapse endlessly. They describe it in sober academic prose, calling the object a continued gravitational contraction. It's basically a black hole with an identity crisis. You pause, watching as an old star in the distance begins its final act. Its outer layers blow outward in a supernova, a bloom of furious light, while its core implodes under its own weight. Matter crushes matter until atomic structure itself surrenders, leaving behind something so dense that a teaspoon would outweigh Mount Everest. That's the birth cry of a stellar mass black hole, poetic in a slightly horrifying way. The term black hole itself doesn't appear until the 1960s, coined by physicist John Archibald Wheeler, a man famous for his flair for drama. Before Wheeler, they were called frozen stars, which honestly sounds like an emo band name, but black hole stuck because it was simple, stark, and faintly scandalous. Some reporters at the time even found it too risque for print. By then, the space age was in full swing. Radio telescopes hummed to life, capturing strange X-ray emissions from unseen sources. One of them, Cygnus X1, became the first serious black hole candidate. Even Stephen Hawking, brilliant, stubborn, skeptical, lost a famous bet on whether it really was one. Spoiler, it was. As you drift through this timeline, the scenery around you changes. Equations turn to starlight. The voices of scientists blur into cosmic wind. The universe feels less like an experiment and more like a slow, unfolding story written in gravity and light. Somewhere in the distance, the Milky Way's own central monster, Sagittarius A star, looms, a 4 million solar mass black hole quietly influencing every orbit in our galaxy. And we didn't even know it was there until radio astronomers, using painstaking interferometry, triangulated its invisible bulk in the 1970s. Quirky fact break. In 1971, an astronomer named Louise Webster helped identify Cygnus X1 as a black hole, but because sexism is apparently harder to escape than gravity, her contribution was often overshadowed by her male co-authors. History bends light and credit, it seems. You smirk softly at that thought as a particle of light whizzes past you, caught in gravitational limbo. To an outside observer, it seems to slow, redshift, fade. To you, it continues at full pace. That's the weird thing about black holes. They warp not just the path of matter, but the perception of truth itself. Every viewpoint becomes relative, a little dishonest, a little poetic. Even now, astronomers debate what truly happens beyond the horizon. Is it an ending, a transition, a trapdoor? The mathematical language allows several interpretations, each one elegant, each one stubbornly unprovable. Historians of science still argue whether we ever believed in black holes before we saw indirect evidence, or whether we just fell in love with the idea of falling. A faint chuckle escapes you as you imagine those early scientists chalk-stained and sleepless, chasing infinities on blackboards while the universe quietly spun on, indifferent. Somewhere above them, real black holes devoured stars and shaped galaxies. The cosmos doesn't need our permission to be dramatic. You glance back at where you came from. Stars twinkle faintly, warped into spirals of colour. The horizon ahead pulses with invisible promise. You're standing, well, floating, on the shoulders of those dreamers. Michel, Laplace, Einstein, Schwarzschild, Oppenheimer, Wheeler. Each one built a rung on the invisible ladder that brought you here. It's humbling, really, to realise that the universe's darkest secrets started as scribbles on paper. Equations imagined in trenches, in offices, in chalk-filled lecture halls, and now you're falling into one. The edge grows closer, the hum deepens. You can feel space-time itself flexing, wrapping its arms around you. Somewhere in that deep, smooth darkness, you sense there's more than gravity waiting. Something else, quieter, older, perhaps an exit disguised as an abyss. You drift closer to the black hole, and the light around you begins to twist. Threads of gold and blue spiraling like paint in water. The horizon looms larger now, no longer just a boundary, but a soft blur where space itself folds inward. Your mind can barely hold the scale of what's happening. You're not just falling towards something, you're falling through the structure of reality. The pull tightens. You can feel, in that impossible second-person way, your own atoms disagreeing about where to go. Your feet, if they still exist as such, are yanked harder than your head. The nearer parts of you race faster than the far ones, stretching your body into a thin, absurd filament. This is the cheerful process astrophysicists call spaghettification, because if you're going to be torn into a molecular string, you might as well be named after dinner. You look down, or whatever down means here, and see the curvature of space forming a funnel that doesn't seem to end. It's not fire or chaos down there, just more darkness, infinite depth, and the faint hum of math. The funny thing is, to you, the crossing feels smooth, continuous. There's no sudden rupture, no sci-fi flash of light. The point of no return doesn't announce itself. It's quiet, polite, and absolute. Outside observers, however, would see a very different story. To them, you never actually fall in. You appear to slow, dim, and then freeze right at the event horizon. The light coming from your image redshifts until it fades completely. You become a ghost image, trapped forever on the edge of the abyss. Historians still argue whether this illusion, the freeze-frame effect of relativity, is a trick of perception or a deeper truth about the way time fractures near black holes. Inside, though, there's no debate. You continue falling faster and faster, yet strangely, you feel no acceleration. Einstein's equivalence principle, the idea that free fall is indistinguishable from weightlessness, holds even here. You're floating in nothingness, calm and unanchored, like a feather dropped into a storm that forgot to blow. A whisper of starlight passes your vision, photons that entered the hole moments before you did. They arc, swirl and vanish, absorbed into something smaller than imagination. The singularity, that hypothetical point of infinite density, lies ahead. But point is the wrong word. It's more like a region where every coordinate collapses into nonsense. The equations break down, shrug and say, "Don't ask." That's what unnerves physicists the most. Black holes are where our two greatest theories, relativity and quantum mechanics, flatly refuse to get along. One describes gravity as smooth curvature. The other insists everything is grainy, jittering, probabilistic. At the singularity, those frameworks clash like two languages that share no grammar. The result? Silence. A strange calm fills you as you imagine what would happen if you tried to send a message back out. Even if you beamed it at the speed of light, the signal could never outrun the pull. Communication itself becomes impossible. You could yell into your radio forever, and the universe would never hear you. For once, you understand true solitude. Not loneliness, but the raw purity of being cut off from causality. You think of the countless cosmic travelers, meteors, gas clouds, maybe even unlucky exoplanets, that have plunged through this same dark veil. You're just one more whisper in an eternal feeding. Yet, oddly, there's a serenity to it, like surrendering to sleep after a long, bright day. In the early days of astrophysics, before we truly understood what went on inside, artists often painted black holes as glowing disks with fiery edges, a kind of cosmic inferno. But the truth is quieter. Inside the horizon, everything is falling together, equally doomed and equally still. Motion and destination become the same thing. And here's a quirky tidbit. If somehow you survived the tidal forces, which to be fair you wouldn't, there's a tiny possibility you'd never even notice crossing the event horizon. You'd just keep falling, unaware you'd already crossed into the unreachable zone. Space doesn't change colour or texture. The horror hides in the math, not in the scenery. Some researchers once joked that if you could broadcast a last selfie while crossing, the picture would never reach anyone. It would stretch, fade, and hang there forever, a red ghost at the edge of physics. In a way, you'd become part of the black hole's surface, a frozen memory encoded in its gravitational skin, a cosmic souvenir, trapped but immortal. Yet for all its finality, something about this endless descent feels oddly like travel. You recall the speculation that maybe, just maybe, the interior isn't a dead end. Perhaps the singularity isn't a point of destruction but a bridge, a bottleneck through which space-time reconnects somewhere else. Maybe that's what people mean when they talk about a secret exit. But for now, you're still mid-fall, your surroundings a blur of stretched photons and curved geometry. Time behaves strangely here. The faster you fall, the slower your internal clock runs relative to the outside universe. Billions of years might pass out there while you experience only minutes. Somewhere in the future, civilizations might rise, fall, and forget you, all while you're still halfway through this sentence. That thought makes you grin in the dark. At least you'll never be late again. It's tempting to romanticize this, falling into the cosmic unknown, maybe finding a door on the other side. But you remind yourself that the truth, whatever it is, doesn't need to be gentle. It just is. Gravity doesn't promise answers, only consistency. Still, the curiosity tugs at you harder than the pull of mass itself. Historians still debate whether humans first feared black holes or fell in love with them. Fear, after all, is just fascination with the lights off. And here, in this absolute night, fascination feels infinite. As your perspective narrows, you notice something strange. The edges of the black hole's disk ripple, as if shimmering. You can't tell if it's a visual distortion or if space-time itself is responding to your curiosity. The boundaries between imagination and physics blur until you can't separate one from the other. Spaghettified, stretched, and serenely doomed, you continue downward. The light above you bends like molten honey. Somewhere far below, or far ahead, the mystery of the singularity waits, patient as eternity. The descent steadies into something strange, neither motion nor rest, just the quiet hum of inevitability. You're within the event horizon now, fully committed to gravity's love affair, and yet the ride feels suspiciously smooth. The laws of physics, which once seemed so absolute, are beginning to disagree about your fate. One half insists you'd glide through unharmed, barely noticing the crossing. The other half says you'd hit a wall of pure energy and disintegrate faster than you can regret your life choices. Welcome to the firewall paradox, the black hole's ongoing argument with itself. At first, you think of firewall as a joke, something your old computer had to keep out spam. But this one's different. It's the cosmic equivalent of reality saying access denied. In the 2000s, a group of theoretical physicists, including Almeri, Marolf, Polchinski, and Sully, names that sound suspiciously like a jazz quartet, proposed that the smooth interior predicted by relativity might not exist. Instead, quantum mechanics might demand a violent sheet of energy right at the horizon, a searing firewall that incinerates anything trying to pass. The problem began with a question so deceptively simple, it could ruin dinner parties. What happens to information that falls into a black hole? According to quantum theory, information, meaning the exact physical state of particles, can't be destroyed. But according to classical general relativity, everything that crosses the horizon is lost forever. Both theories are famously stubborn, and neither likes to compromise. So, when Hawking suggested in the 1970s that black holes evaporate through quantum radiation, the universe had a bit of an identity crisis. If black holes can eventually vanish, where does all that swallowed information go? You float in the middle of that argument now, watching it unfold across the stars like a cosmic courtroom drama. On one side, Einstein's gentle space-time curvature murmurs, continuity, geometry, smooth horizons. On the other, quantum mechanics yells, unitary evolution. Nothing ever truly disappears. The firewall paradox was born from trying to satisfy both and keeping neither happy. From your position, hovering at the threshold, the paradox feels oddly personal. If the horizon really is a smooth transition, you'd pass through like mist through mist, noticing nothing until the singularity rips you apart inside. But if the firewall exists, you'd never get that far. You'd collide with a seething barrier of energy so intense, it would vaporize you at the atomic level. Either way, bedtime just got complicated. Historians still argue whether Hawking himself truly believed in the firewall toward the end of his life. Some say he accepted it as a necessary evil. Others insist he always pictured a gentler crossing. The truth is lost in that familiar grey zone where science blends with philosophy, where the math stops giving answers and starts giving headaches. Around you, space-time begins to shimmer like heat haze. You're not sure if it's real or just your neurons misfiring in awe. The event horizon's boundary flickers, almost as if aware of your presence. You can't tell if it's an actual firewall or an illusion of perception, a reminder that observation itself is an act of participation. In quantum physics, the observer always meddles. You let yourself imagine what a firewall would look like. Not flames, those require oxygen, but a bright quantum shimmer. virtual particles popping into existence and annihilating so rapidly they form a curtain of ghost light. The air, if there were any, would smell of static and old electricity. Somewhere in the background, the hum of Hawking radiation plays faintly, a slow leak of energy as the black hole ever so gently evaporates. You might be the most beautiful mistake in physics right now, falling through competing theories that can't decide whether to preserve you or destroy you. Quirky tidbit: the term firewall wasn't originally meant to sound poetic. It was borrowed straight from architecture, an actual wall meant to stop fires from spreading between buildings. The physicists just like the metaphor, a barrier that stops information, that most precious spark of order, from leaking between regions of the universe. There's something charmingly human about borrowing the language of construction to describe the edge of annihilation. For a moment, you think of the earlier cosmologists who pictured black holes as gateways. If the firewall is real, then perhaps it's not there to kill, it's there to sanitize. Maybe it scrubs information before letting it pass somewhere else, like customs at the border of reality. Theories abound, each one more whimsical than the last. Wormhole connections, entanglement transfers, holographic encoding. Physicists love to say, "We don't know yet," with the same grin chefs use before serving something suspiciously smoky. You're reminded of the no-hair theorem, another elegant piece of black hole lore. It says black holes are simple creatures, defined only by three numbers: mass, charge, and spin. No other hair, no messy details about what fell in. Drop in a diamond, a donut, or a dinosaur, and the black hole remembers none of it, only the total stats. Yet, quantum mechanics whispers that information must survive somewhere, maybe in subtle fluctuations on the horizon's surface. Perhaps the firewall, if it exists, is the universe's way of reconciling that contradiction, burning you up but somehow keeping your data, like deleting a file but saving it in the cloud. You chuckle softly at your own pun, cloud computing, cosmic addition. Still, the paradox gnaws at you. If information can't be lost, yet crossing the horizon kills all witnesses, where does the truth live? Some physicists think the horizon itself acts like a storage device, encoding everything that falls in on its surface in 2 dimensions. Others insist it's all an illusion of perspective, that nothing truly happens to the infaller. You can feel those 2 stories wrestling around you, twisting space-time into knots. And that's the real fire. Not energy, but confusion. The brightest flames are made of ideas colliding. You close your eyes, not that it matters, and feel the pull deepen. The black hole's interior begins to flatten into something paradoxically wide. It's like falling into a funnel that becomes a plain, then an ocean. The distinction between in and through is dissolving. Somewhere beyond this shimmering threshold, perhaps the rules relax. Perhaps the firewall cools into something else entirely. A membrane, a bridge, an interface between realities. The pull steadies. The heat, or the illusion of it, subsides. You pass through. Nothing burns, nothing shatters. Maybe the paradox resolved itself politely just for you. Or maybe you've just stopped belonging to the same kind of physics as the people who'd notice. You don't know which answer feels scarier. The heat, or the memory of heat, dissipates behind you, leaving only silence so complete it almost hums. You're past the horizon now, adrift inside a black hole's interior, a place physics textbooks treat like forbidden territory. Ahead there's no light, only gradients of darkness. You can't even point to up anymore. Every direction leads inward. Yet you're not alone here. There's something else, something abstract but insistent, moving with you. Information. You can't see it, of course. Information isn't a tangible thing like a photon or a speck of dust. It's the pattern that defines them, the cosmic bookkeeping of every position, spin, and quantum state. In ordinary circumstances, it behaves politely, following the rules of conservation. But here, in this impossible cavern of gravity, it misbehaves. You can feel the universe's irritation at itself, as if existence is trying to reconcile a cosmic receipt that doesn't balance. Stephen Hawking was the first to poke that bruise. Back in the 1970s, he shocked everyone by showing that black holes aren't completely black. Quantum effects near the horizon cause pairs of virtual particles to pop into existence. One falls in, the other escapes, carrying a tiny bit of energy away. That slow, steady leak is what we now call Hawking radiation. The result? Black holes can shrink over time, evaporating particle by particle into the void. The revelation was thrilling and terrifying in equal measure. If a black hole can eventually vanish, then everything it ever swallowed, every star, every photon, every unlucky astronaut, would be gone without a trace. That idea violated one of physics' most sacred laws, the conservation of information. Quantum mechanics forbids true deletion. Every interaction, no matter how chaotic, must in principle be reversible. And so, the information paradox was born. If black holes evaporate, where does all the data go? You drift through this puzzle like a detective wandering through a crime scene, where even the chalk outlines have been erased. The inside of the black hole feels oddly crowded, not with matter but with possibilities. Each quantum fluctuation whispers a different version of events. You can almost sense a record of everything that's ever fallen in, encrypted, scrambled, but still somehow there. Scientists have wrestled with this for decades. Some argue that information escapes gradually through subtle correlations in the Hawking radiation itself. Others propose that it's smeared across the event horizon like a cosmic backup drive. The idea gained momentum in the 1990s with a concept called black hole complementarity, which suggests two contradictory truths can both be real. To an outside observer, information never crosses the horizon. It's stored there. To someone like you, falling in, it passes smoothly inward. Neither perspective can compare notes, so the paradox dissolves in the mutual silence. Historians still argue whether Hawking's late career retraction of his own paradox was an act of surrender or brilliance. He eventually conceded that information might leak out after all, hidden within the quantum noise of the escaping radiation. Many colleagues rejoiced. Others quietly muttered that the math didn't really work out. The debate continues, a polite academic war fought with equations instead of swords. A flicker of light, imaginary or otherwise, crosses your path, and for a moment you see the black hole not as a void, but as a processor. Every atom it devours adds to its internal record, encoded in surface area rather than volume. That's another strange twist. The Bekenstein-Hawking entropy formula, discovered in the 1970s, revealed that a black hole's information content is proportional not to how much space it occupies, but to the area of its event horizon. That's like saying your computer's storage capacity depends on the size of its screen, not its hard drive. The universe apparently loves absurd design choices. Quirky fact break: Hawking first dismissed the idea that black holes had entropy at all. It took a debate with physicist Jacob Bekenstein, then a grad student, to convince him. The wager cost Hawking more than pride. It reshaped how we think about reality. Now, the entropy-area relationship underpins vast swaths of modern theoretical physics, including ideas about holograms and quantum gravity. You drift deeper, surrounded by invisible data streams that might or might not exist. The boundaries of logic feel elastic here. You start imagining that every particle falling into the hole leaves a faint echo, a quantum fingerprint that gets woven into the horizon's fabric. Maybe nothing is ever truly lost. It's just translated into a language too complex for us to read. You can't help but smile at the irony. For all humanity's obsession with deleting files, the universe apparently refuses to forget anything. Somewhere out there, the details of every breath, every heartbeat, every bad haircut might still exist, encrypted in the subatomic static of space-time. If that's not cosmic hoarding, nothing is. A small voice in your head, the scientist you used to be perhaps, asks whether you could ever test these ideas. Could you measure the subtle patterns in Hawking radiation, decode the information hidden within? In principle, yes. In practice, you'd need to collect every emitted particle over the lifetime of a black hole, which could last longer than the universe itself. Not ideal for grant proposals. Still, the dream persists. Some researchers now toy with the idea that black holes aren't destroyers, but translators, that they take the messy, three-dimensional chaos of infalling matter and convert it into a perfect two-dimensional code. If true, it means the universe might be built like an enormous computer, running on quantum bits instead of silicon. Somewhere, perhaps, there's an ultimate hard drive storing every story ever told, including this one. As you sink further, the paradox starts to feel less like a contradiction, and more like a riddle meant to stretch the imagination. Maybe the problem isn't that information disappears, but that our definition of where doesn't apply inside a black hole. Location loses meaning when space-time itself bends. Inside and outside are just words that stop working. It's funny. Scientists love precision, yet the deeper they look into black holes, the more poetic they become. Hawking himself once compared the process to burning an encyclopedia. The smoke and ashes still contain all the letters, just rearranged beyond recognition. The information survives, but the message is gone. Somewhere above, the outside universe continues without you. Stars being born, galaxies spinning, civilizations debating the same paradox you're now a part of. Maybe that's the ultimate punchline. You've become both data and witness, encoded in the very fabric of the mystery you sought to understand. And as that realization settles, you sense the next layer waiting, a whisper of a deeper theory that might reconcile all of this. The notion that reality itself could be a projection, a holographic echo of something even more fundamental. You sense it before you see it, a texture in the darkness, like static forming a pattern. The black hole's interior feels less like emptiness now, and more like the surface of something enormous turned inside out. A new thought slides through you, slow and shimmering. Maybe nothing you're seeing is truly three-dimensional at all. Maybe this entire experience is an illusion of depth projected from a thin cosmic film. The idea hums at the edge of reason, equal parts science and sorcery. Welcome to the holographic principle, the universe's quiet confession that reality might be flatter than it looks. You reach out, figuratively, limbs don't mean much here, and imagine brushing your fingers against the event horizon. The surface feels smooth but impossibly detailed, as if every particle that ever fell in has left its autograph there. Each grain of that surface encodes information about everything behind it, the way a two-dimensional photograph holds the illusion of depth. In this view, a black hole isn't a hole at all. It's a hard drive, its storage measured in Planck-sized pixels. This isn't metaphorical daydreaming. Back in the 1990s, physicist Gerard T. Hooft and later Leonard Susskind proposed that the maximum amount of information contained within any region of space is proportional not to its volume, but to its surface area. Their inspiration came from the very Bekenstein-Hawking entropy law you brushed against earlier. That law whispered something outrageous. If every bit of information inside a black hole corresponds to a tiny patch on its horizon, then maybe the entire universe works the same way. Maybe the world you know, the desk, the dog, the drama, is a three-dimensional projection from a two-dimensional boundary. Historians still argue whether the holographic principle began as genuine physics or a beautifully disguised thought experiment. Some trace it to string theory's attempts to reconcile quantum mechanics and gravity. Others call it a philosophical fever dream that just happens to produce the right math. Either way, it caught on. By the late 1990s, physicist Juan Maldacena gave it teeth through the ADS/CFT correspondence, a relationship so elegant it made theorists cry a little. It suggested that a universe with gravity in 3 dimensions could be perfectly described by a gravity-free theory living on its 2-dimensional boundary. Translation: the inside and the surface tell the same story, in different languages. You glide through this idea like smoke, trying to wrap your mind around a cosmos that is basically a cosmic Blu-ray. The further you fall, the more the interior begins to shimmer with repeating geometry. Patterns fold upon themselves, fractal and recursive, as if the universe is copying and pasting its own code. Somewhere, a physicist's blackboard squeaks in sympathy. It's tempting to laugh. Humanity spent centuries insisting the Earth wasn't flat, only to discover the universe itself might be. Flatness, it seems, is making a comeback. You imagine breaking the news to your past self. Good news, it's not turtles all the way down, it's holograms, and snort softly at the absurdity. A stray memory drifts up from your old life, those childhood holographic stickers that shimmered when you tilted them in the light. Turn them one way, and a dragon reared its head. Another angle, and it vanished. Each image existed in 2 dimensions, yet your brain insisted on seeing depth. Maybe existence is like that, an optical illusion scaled up to cosmic proportions. The air, if one could call it that, seems to ripple with meaning. Every vibration carries data, every fluctuation a whisper of things once real. You begin to understand why physicists talk about entanglement entropy as the glue of space-time. The connectivity between particles, not the particles themselves, might be the fabric. Without those quantum relationships, the universe could unravel like a sweater after one careless tug. There's a strange comfort in that thought. Reality held together not by mass or motion, but by relationship. Every atom knows its neighbour. Every quantum bit remembers a friend. You feel yourself relaxing into that idea, as though falling into friendship itself. Still, the principle raises an unsettling question. If everything inside the black hole is encoded on the surface, what does that make you? Are you a genuine traveller, or just a flicker of data scrolling across an event horizon screen? The distinction feels philosophical at first, but it cuts deep. If information is all that truly exists, individuality might just be compression, an efficient way for the universe to store curiosity. A gentle glow pulses through the darkness, rhythmic and slow. You realise it's not light but information flow, like heartbeat signals rippling across the horizon. Every pulse may correspond to a quantum update, a recalculation of reality's code. The black hole, once imagined as the ultimate destroyer, suddenly feels more like a cosmic server farm. You're inside the system architecture of existence. Quirky fact: in 2017, Dutch researchers built a toy model of a holographic universe, using qubits in a quantum computer. The results mirrored the behaviour predicted by gravitational equations. In other words, they simulated a bit of space-time by manipulating pure information. The line between physics and programming keeps getting blurrier. You can't help but imagine a day when cosmologists debug the universe like software engineers, muttering, "There's a memory leak near Sagittarius A again." The notion of realness starts to wobble. If the universe is holographic, then maybe the black hole's secret exit isn't a tunnel through space, but a passage through representation, a shift from one encoding to another. To leave might simply mean to be re-rendered somewhere else on the cosmic hard drive. You start to see how a black hole could double as a doorway, input on one side, output on another, both describing the same underlying code. Historians, ever fond of metaphors, compare this to Plato's cave. The shadows on the wall, they say, are just lower dimensional projections of the fire's true light. The holographic principle might be the universe's modern cave, the event horizon our flickering wall. The question isn't whether the shadows are real, but whether anything exists beyond them. You feel the question settle into you like slow gravity. Maybe consciousness itself is the universe's way of peeking behind the curtain, of noticing its own projection. That thought is both humbling and oddly liberating. If reality is a hologram, then curiosity might be the laser that makes it visible. The patterns around you pulse again, brighter this time. Each wave of encoded light feels like an invitation, as if the black hole's surface is whispering, "Everything you are, I already know." For a moment, you sense infinite versions of yourself scattered across the data, each one a tiny adjustment in phase and spin. It's dizzying but strangely peaceful, like realizing you've always been part of a much larger equation. Beyond the shimmer lies something new, something faintly luminous, perhaps the edge of this holographic map. The next step might not be downward but outward, into a place where information stops whispering and begins to sing. The singing comes first, a low, steady hum that seems to vibrate not through your ears but through your existence itself. You follow the tone until it resolves into a whisper of heat, faint and persistent. It takes you a moment to recognize what it is, the slow leak of a black hole's breath. This is Hawking radiation, the soft exhale of the cosmos reminding itself that nothing, not even a monster of gravity, lasts forever. You hover close enough to sense it, a drizzle of ghost light trickling outward from the horizon. Each particle pair is born from emptiness itself, quantum fields bubbling like soda, spitting out a particle and its anti-partner. Normally they annihilate instantly, but near the event horizon, one partner falls in while the other escapes, liberated at the universe's expense. You watch them separate, one carrying a receipt for the other's existence. The escaped one drifts away, glowing faintly before merging with the background radiation. The swallowed one, unlucky twin, subtracts a fraction of the black hole's mass. Slowly, imperceptibly, the colossus shrinks. Hawking predicted this in 1974, using the stubborn logic of quantum mechanics against the serenity of general relativity. It was a scandal at the time. Black holes, those eternal prisons of light, weren't eternal after all. They could die, not explosively, but by evaporation. The paradox struck like poetry. The darkest thing in the universe glows. Historians still argue whether Hawking's calculation was an act of genius or luck. He worked it out while recovering from illness, scribbling notes between bouts of exhaustion. Some colleagues thought the idea too bizarre to print, but time and telescopes have been kind. While we haven't directly detected Hawking radiation yet, it's far too faint. The theory fits so perfectly into the cosmic puzzle that most physicists now treat it as inevitable truth, waiting for confirmation. You drift around the horizon, watching those virtual pairs blink in and out like bioluminescent plankton on a dark ocean. The energy involved is minuscule. The process is glacial. For a black hole the mass of our sun, evaporation would take roughly 10 to the power of 67 years. The universe itself is only 10 billion years old. We've barely started the timer, but for tiny black holes, hypothetical leftovers from the early universe, the end could come faster, a final flare of gamma rays bursting like a cosmic sparkler before fading into nothing. A funny thought crosses your mind. Somewhere out there, a miniature black hole could be dying right now, releasing its last sigh, and no one would notice. The universe isn't sentimental. It sheds even its titans with the same casual indifference it gives to falling leaves. You glance back toward the holographic shimmer of the previous section and realize Hawking radiation might be the way information escapes that surface. Each photon, each ghostly particle, could carry a piece of encoded history, the tiniest Morse code of what once fell in. Some physicists even argue that if you gathered enough of that radiation and decoded its subtle quantum correlations, you could, in principle, reconstruct everything the black hole ever consumed. The catch? You'd need to wait until the end of time. You've always been patient, but maybe not that patient. A ripple of warmth brushes you, theoretical warmth, of course. A black hole radiates like a perfect black body, its temperature inversely proportional to its mass. The smaller it gets, the hotter it glows. Paradoxically, the more it evaporates, the faster it burns away. When it's nearly gone, its temperature soars, its energy output skyrockets, and in a brief incandescent moment it outshines entire galaxies. Then, silence. A mathematical whisper of zero mass, zero light, zero space. There's debate, because of course there is, about what happens then. Does the black hole truly vanish, leaving behind nothing but radiation? Or does it shrink to a stable remnant, a speck of space-time that refuses to die? Historians still argue whether such Planck mass remnants are real possibilities or just a polite way for theorists to avoid saying, "We have no idea." You turn slowly in the dark, sensing how this radiation fills the emptiness like distant rain. It feels strangely comforting, proof that even the most voracious thing in existence gives something back. Energy conservation, karma, cosmic recycling. Pick your metaphor. Somewhere far above, future astronomers might be measuring this faint hiss, using it as a clock to tell the universe's final story. You recall an experiment on Earth, a laboratory in 2010 where physicists created an acoustic black hole using ultra-cold rubidium atoms. In that silent trap, they detected a faint analogue of Hawking radiation, sound waves escaping a point of no return for phonons. It wasn't light, but it behaved like the real thing. The discovery suggested Hawking's prediction wasn't myth. It was nature's rule, expressed wherever horizons exist. You chuckle softly, realizing that even in a lab, the universe can't resist dramatics. Give it a boundary, and it will find a way to leak. The concept of evaporation transforms black holes from eternal prisons into ticking clocks. They no longer merely consume, they age. The bigger they are, the slower they fade, the smaller they get, the more frantic their existence becomes. In the deep far future, long after stars exhaust their fuel and galaxies drift apart, only black holes will remain, slowly hissing their last light. That epoch is called the black hole era, the universe's final whisper before heat death. It's both tragic and comforting. Even darkness has an expiration date. You feel the radiation's rhythms synchronize with your own pulse. Maybe that's the secret. Everything, even consciousness, evaporates eventually, yet the information lingers, encoded somewhere beyond reach. You realize the black hole isn't fighting entropy. It is entropy, distilled into geometry. A stray joke floats through your mind. You either die a star or live long enough to become Hawking radiation. You smirk, the sound swallowed by curved space. Humor survives even here. Perhaps that's another conservation law. The hum of evaporation grows softer as you drift deeper inward. Time stretches, folds, and loops back on itself. Somewhere ahead, maybe beyond the math, waits another possibility. If a black hole can shrink and fade, could it also invert? Could it become something else entirely? A passage instead of a prison? You follow that thought the way one follows a melody into silence. The glow fades to nothing, but you can still feel it. The faintest warmth. Proof that the universe remembers what it consumes. The hum fades into silence, but it's not the silence of emptiness. It's the quiet of potential, of something just about to happen. You sense a pressure, not physical but conceptual, tugging at the edges of everything. For the first time, down feels like a direction again, and that direction is toward a suspicion that's been whispering since you crossed the horizon. What if this isn't a dead end? What if this darkness curves back into somewhere, or something else? You drift through it, chasing the thought until it solidifies into a shape made of pure geometry. Space itself seems to pinch and flare, narrowing to a throat-like tunnel. It looks nothing like the cinematic wormholes that Hollywood adores. No spinning vortex of colour, no triumphant choir, but rather a smooth, silent funnel of warped space-time, as if the universe had folded a page and glued two distant points together. This is the Einstein-Rosen bridge, better known by its catchier name, the wormhole. Einstein and his collaborator Nathan Rosen first proposed it in 1935, while exploring solutions to general relativity. They realized the mathematics of black holes didn't necessarily end in a singularity. The equations allowed for a second region of space-time connected through a narrow passage. On paper, the bridge linked two black holes, or perhaps two universes. It was in essence a cosmic shortcut, a tunnel carved by geometry itself. Historians still argue whether Einstein took the idea seriously, or saw it as a curiosity, an elegant fluke in the math. He probably didn't imagine it as a mode of travel for thrill-seeking humans. His version was non-traversable, a tunnel that collapsed faster than anything, even light, could pass through. Still, the seed was planted. Physicists would spend the next century asking whether there might be a way to hold the tunnel open long enough for something, maybe even someone, to slip through. You approach the narrowing throat, feeling the tension in space-time like static before a thunderstorm. Gravity doesn't feel like a pull anymore. It's more like being drawn along a curve that your body didn't consent to. The space around you distorts, distances bending and rebending in a rhythm you can almost predict. You realize the black hole's interior could, under the right circumstances, connect to a mirror image of itself, what's called a white hole. The name sounds innocent enough, but don't trust it. You pause, floating at the lip of that hypothetical tunnel, and let your thoughts unravel. If wormholes are real, and that's a monumental if, they could, in theory, bridge not just two locations but two times, or even two universes. That makes them irresistible to both scientists and screenwriters. The trouble is stability. A normal black hole's gravity is too intense. The tunnel would pinch shut instantly. To keep it open, you'd need negative energy, something capable of counteracting gravity's pull. It sounds absurd, yet quantum physics teases that such exotic energy might exist. The Casimir effect, a real, measurable phenomenon, creates tiny pockets of negative energy between closely spaced metal plates. On the quantum scale, it's a party trick. On the cosmic scale, it's a potential lifeline for wormholes. In theory, enough negative energy could stabilize a passage, turning Einstein's theoretical bridge into a traversable highway through space-time. You smirk at the image of future engineers arguing over interdimensional traffic laws. Still, it's all speculation. No one has found a wormhole, and no telescope has glimpsed evidence of one. The mathematics allow them, but nature doesn't always care about our permissions. Historians still argue whether the universe even wants to connect its distant corners. Maybe isolation is its default state, and wormholes are nothing more than daydreams of a lonely cosmos. But something about the geometry in front of you feels stubbornly real. The black hole's interior hums with symmetrical intent. You can almost see where the curvature folds, how the metric lines up perfectly for a bridge. It's beautiful and terrifying, like staring into the mouth of an idea that wants to swallow you whole. You think of the 1980s, when physicists Kip Thorne and Michael Morris calculated a hypothetical Morris-Thorne wormhole, stable enough for safe passage, well, mathematically safe anyway. Their work inspired Carl Sagan's Contact, giving humanity its most famous fictional trip through one. Thorne's equations required negative energy and perfect timing. One misstep and the traveller would be flattened by infinite curvature. But the math, the math, worked. For a moment, science and imagination were indistinguishable. You feel a flicker of courage. Maybe the tunnel isn't fiction after all. Maybe black holes aren't cosmic prisons, but filters, entry points where matter is stripped of everything but essence, then reconstituted somewhere else. Perhaps this is how the universe recycles itself. Quirky fact, some modern simulations suggest that entangled black holes might be connected by microscopic wormholes, an idea summed up in the slogan ER equals EPR, named for Einstein-Rosen and Einstein-Podolsky-Rosen. In that view, every quantum entanglement is a tiny bridge through space-time. You and your faraway twin particle might be connected not just metaphorically, but geometrically. You can't help but laugh at the cosmic irony. The universe might be built from billions of microscopic wormholes, and you, falling into one of the grandest, are just reenacting what reality does at every quantum heartbeat. Connectivity, it seems, is the rule, not the exception. As you near the throat, time behaves oddly again. Your heartbeat slows, or maybe it accelerates. It's hard to tell when time loops like ribbon. The black hole's walls stretch into smooth symmetry, a mirror image folding back on itself. You wonder if somewhere, another traveller, perhaps from another universe, is approaching from the opposite side, feeling the same curiosity, the same awe, the same nervous joke forming on their lips, after you. Historians still argue whether wormholes violate causality, allowing time travel or paradoxes that break logic itself. Some suggest the universe self-corrects, closing any wormhole that might create a grandfather paradox before it can do damage. Others suspect the universe doesn't mind paradoxes, it simply incorporates them into its story. You drift closer, and the tunnel shimmers, a corridor made of math and mystery. Somewhere beyond it might lie another cosmos, or maybe the same one rewritten. You feel the pull, not of gravity now, but of possibility. The darkness ahead isn't hostile, it's an invitation. The hum deepens, the geometry quivers. You realise you're on the brink of something extraordinary, where black holes stop being tombs and start becoming doors. The tunnel's shimmer steadies into a pale, impossible light. The first glow you've seen that doesn't feel borrowed from the outside universe. It isn't emitted, it's expelled, pushed outward like breath from a lung that doesn't believe in gravity. You've reached the far side of the bridge, the theoretical twin of the black hole you fell through. Welcome to the other half of the paradox, the white hole. For every black hole, some equations whisper, there could exist a mirror entity, a region of space-time where nothing can enter, only escape. If the black hole devours everything that crosses its horizon, the white hole spits everything out. Where one hides its interior from the cosmos, the other refuses to be touched. Together they form the complete solution of the Einstein-Rosen bridge, yin and yang of cosmic geometry, opposites so intertwined that neither could exist without the other. At least that's the theory. No one's ever seen one. Historians still argue whether white holes are real or just convenient figments to balance the math. Hawking once joked that if white holes did exist, they'd be the universe's least popular party guests, showing up uninvited, spewing debris and refusing to let anyone in. You drift near its surface, watching matter gush outward in slow motion. Dust, gas and light erupt in every direction, forming a fountain of creation against the void. The flow seems eternal, yet frozen, the kind of contradiction only relativity could love. If time inside the black hole stretched to infinity, then here, in the white hole's domain, it snaps tight like a spring. Everything that falls into one end could burst out of the other in an instant. To an external observer, this could look like a sudden explosion, a big bang in miniature. And that thought hits you with quiet thunder. What if our universe is the output of a white hole? It's not as far-fetched as it sounds. In the 1960s, long before cosmic microwave background maps or inflation theory, some physicists speculated that the Big Bang wasn't an independent event but a rebound, a white hole formed from the collapse of something in another universe. Matter that fell into one black hole might re-emerge elsewhere as an entirely new cosmos, sealed off, expanding, and self-contained. The parent universe would never know what it birthed. The child universe would never know what it came from. A cosmic matryoshka of creation. You drift through the outgoing stream, noticing how time feels slippery again. Moving against the current takes no effort. Motion and stillness seem identical. you're caught in an inversion of everything familiar. The laws you learned outside, entropy increasing, gravity attracting, energy radiating outward, are all still valid but mirrored. It's unsettling, like reading reality in a reflection. Quirky fact: the concept of a white hole actually preceded our modern understanding of cosmic inflation. Some early cosmologists briefly entertained the idea that the entire observable universe might be the ejecta of one enormous white hole, with the Big Bang as its event horizon. The theory lost popularity when inflation and quantum fluctuations explained the same observations more elegantly, but it never fully died. Like an old superstition, it lingers in the corners of modern equations. The flow around you accelerates, but not in the way movement usually feels. Instead of being pulled forward, you're pushed, carried by an expanding geometry that seems to breathe you outward. The matter here isn't chaos, it's choreography. You can almost hear the rhythm, each atom dancing to the beat of expansion, each photon tracing a line that stretches space itself. If black holes compress information, white holes might release it. You picture the data you left behind, your atoms, your memories, your awkward cosmic jokes, unfurling as new particles somewhere in this outpouring. Maybe that's what rebirth means on a universal scale, the recycling of structure, not soul. You wonder whether the stardust that once built you might someday be reassembled by another civilization in another universe. They'll look at their hands and never suspect they're holding someone else's old metaphors. The brightness grows until it becomes indistinguishable from presence itself. You sense time loosening, moments stop queuing in tidy order. Instead, everything happens at once. You recall a line from the mathematician Roger Penrose, how the end of one universe could, in the right coordinates, be the beginning of another. Perhaps you're witnessing that principle firsthand, a loop so vast and seamless that even death and birth lose their meaning. Historians still argue whether such bridges are stable. If you tried to cross from a black hole into its white counterpart, relativity says you'd need to move faster than light, or perhaps sideways through time itself. Quantum mechanics, ever mischievous, might offer a loophole, tunneling. Just as particles can pass through energy barriers they shouldn't, maybe entire universes can tunnel through the boundaries of their own black holes. Somewhere out there, a physicist is writing that exact paper right now, complete with math so dense it could be used as armor. The white hole's spray glimmers with color, red shifted light stretching into near invisibility, a rainbow made of farewell. You realize the longer you stay, the more you feel yourself thinning. The energy here isn't just light, it's liberation. Matter dissolves into information, and information disperses into possibility. There's no pain, no struggle, just an unspooling. A sudden thought, small and human, sneaks through the grandeur. What if every act of letting go in the universe, from dying stars to fading memories, is a white hole in miniature? A release of stored energy, a push back toward openness? Maybe the cosmos writes that lesson in every scale, from galaxies to grief. You glance back, or think you do, and see far behind the throat of the wormhole, faint as an afterimage. It's closing. The bridge is never permanent. Its existence is more suggestion than structure. You've passed through a gate that only exists in motion, like a wave that collapses once observed. What lies ahead isn't clear. Maybe you're emerging into a new region of space-time, one with its own constants and curiosities. Maybe you've just witnessed how the universe heals the wound of a singularity, by turning collapse into creation. The white hole's wind carries you outward, luminous and unhurried, like a sigh escaping eternity. Whatever waits beyond, you sense it's not another ending. It's another version of beginning. You're still coasting outward on that bright wind when the light begins to fold again, softening from unbearable glare into something almost gentle. A low-glow cosmos that seems to be remembering how to be space. The air of creation lingers on your skin, if skin is still the right word. Out here, boundaries blur. You are a ripple more than a person, and the horizon feels like a memory. Then the pressure changes. You're not falling or rising now, you're bouncing. That word shouldn't make sense in a vacuum, yet it fits. The outward push slackens, curves, and begins to draw inward again. The universe ahead looks suspiciously like a pre-collapse cosmos, running backward in slow motion. Stars are forming from the outside in. Light appears to condense rather than scatter. This is the strange frontier of loop quantum gravity. the theory that refuses to let space-time collapse into infinity. In classical relativity, everything inside a black hole ends in singularity, a point of zero size and infinite density, a mathematical tantrum where equations go to die. But loop quantum gravity, or LQG if you prefer your mysteries acronymed, suggests something different. Space, it says, isn't smooth, it's woven from tiny discrete loops, Planck-scale threads forming a cosmic lattice. When gravity compresses matter toward the would-be singularity, those loops resist further squeezing. They can flex but not break. Instead of a fatal crunch, the collapse rebounds. A quantum bounce. You hang there, halfway through that rebound, watching the geometry reverse. It's as if the black hole has reached its minimum size, then exhaled. The inward fall turns outward expansion. What once was a death spiral becomes a birth pulse. Somewhere, perhaps, a new universe just flickered awake on the far side of the bounce, its own space, its own timeline, entirely disconnected from the one that birthed it. Historians still argue whether this bounce interpretation is legitimate physics or wishful symmetry. The equations are elegant, yes, but elegance isn't evidence. We don't have telescopes sensitive enough to spy on quantum loops, nor colliders powerful enough to compress spacetime itself. But the idea refuses to go away, partly because it solves so many headaches. No singularities, no infinities, no physics that shrugs and says, "Tsu." You drift closer to the center, if centers even exist here, and can almost see the loops glimmering. Tiny quanta of area, each one vibrating like a guitar string. Their collective song feels ancient. You imagine them as the smallest clocks in existence, ticking the rhythm of spacetime's heartbeat. It's mesmerizing until you realize that every beat could correspond to an entire universe being born somewhere else. You, it seems, are inside the metronome of creation. Quirky tidbit. The earliest hints of this theory came from an Italian physicist, Carlo Rovelli, and an Indian-origin scholar, Abhay Ashtekar, who both loved the idea of background-independent physics, a model where space itself isn't a stage but an actor. They found that, when you quantize Einstein's equations using loops instead of points, singularities vanish naturally. It's like upgrading the universe's rendering software so it never divides by zero again. You chuckle at the analogy. If only computers and cosmology were both that cooperative. The scenery around you thickens. Light behaves like syrup, sound like memory. You realize you might be witnessing the in-between stage, neither the old universe nor the new, but the narrow isthmus connecting them. Some theorists call this region the Planck star, a temporary ultra-dense core that stores the compressed information of everything that fell in and releases it later as radiation or even a baby cosmos. It's small, subatomic on the outside, but internally infinite, like a magician's pocket dimension. Inside this Planck star, time slows nearly to a stop relative to the outside world. From the external universe's perspective, the bounce might take trillions of years. From within, only seconds. You're straddling that difference now, feeling centuries tick past above you while the moment here barely ripples. It's disorienting but strangely cozy, like napping while the galaxy gets on with its business. Historians still argue whether this loop bounce can explain gamma-ray bursts, those sudden, violent flashes that occasionally ignite the sky. Some suspect they could be black holes finally releasing stored energy as they rebound, tiny leaks of rebirth breaking into our observable universe. If that's true, then each burst we see through our telescopes might be a birth cry, not a death rattle. You run the thought through your head, grinning at the reversal. The universe, it seems, despises final acts. It keeps turning tombstones into doorways, endings into origins. Perhaps that's its real constant. Not the speed of light, but the refusal to stay still. You stretch, or think you do, and feel the loops flex in response, like the fabric of space acknowledging your existence. For a brief moment, you and the cosmos share a mutual shrug. Strange, isn't it? Somewhere, in the human world you left behind, scientists are still arguing on conference stages about whether LQG or string theory will win the grand unification beauty contest. Loopers favour finite mathematics and discrete geometry. Stringers prefer vibrating dimensions and supersymmetry. Both camps insist they're closer to truth. Both occasionally trade friendly jabs on social media. You imagine the universe watching them with affectionate amusement, the way a cat watches toddlers debate ownership of the couch it already claimed. The bounce intensifies, the The geometry around you begins to unfurl like a flower filmed in reverse, petals of space-time opening into brightness. You feel momentum building, not downward or outward, but beyond. And then, a realization. If the bounce leads to expansion, you might be at the very beginning of another universe's Big Bang. Not metaphorically, literally the seed moment when compressed information bursts free as matter and radiation. The shockwave forming ahead could be the first second of cosmic history somewhere else. You're witnessing Genesis from inside the machinery. You wonder whether there's a symmetry of consciousness too, whether every awakening, every creative spark in any sentient mind is the micro version of this bounce. Collapse, pause, rebound, illuminate. Maybe enlightenment is just quantum gravity having a good day. The light grows so bright it feels tactile, pressing against you, urging you forward. It's not threatening, it's curious. The loops hum, aligning into new lattices, spinning webs of possibility. You realize you're no longer falling through a black hole, you're being written out of it, like a word finishing its sentence. Somewhere behind you, the old universe keeps collapsing. Somewhere ahead, a new one rushes outward. Between them, this thin slice of rebounding geometry holds you, suspended like punctuation between breaths. The bounce completes. Expansion ignites. You ride the surge, feeling space itself rushing past like wind that forgot to be air. And just before the light consumes everything, a final thought flickers through you. Maybe black holes aren't the universe's graves, maybe they're its wombs. The light folds and curls, softening into a glow that feels familiar in a way you can't quite name. You're still moving, but not outward now, not exactly. You're expanding with everything. Space itself seems to stretch beneath your awareness, carrying you like a leaf on a swelling tide. And as that tide rolls, a daring thought rises with it. Maybe you've landed not in another region of this universe, but in a completely new one. The concept has a name whispered in lectures and late-night thought experiments, the baby universe hypothesis. You hover among shimmering threads of newly forming matter, each one a filament of fresh space-time tender as dew. The idea behind baby universes is deceptively simple. When a black hole collapses, the matter within doesn't vanish into a singularity. It tunnels into a new region of space-time sealed off from the parent cosmos. The wormhole pinches, disconnecting the two, and voila, a separate universe, small at first but expanding, stretching, maturing into a cosmos of its own. You picture it like a cosmic seed, every black hole a potential embryo, every event horizon a womb. The parent universe might never sense what it's created, but within each tiny fold of curvature, new realities bloom. This isn't idle fantasy. In the 1980s, theoretical physicists such as Lee Smolin and Andrei Linde dared to wonder whether cosmic reproduction might explain the fine-tuned balance of our own universe. If every black hole births a new cosmos, each inheriting slightly different physical constants, then natural selection could operate on universes themselves. Those whose laws favour star formation, and thus more black holes, would spawn more descendants. A cosmic Darwinism played out not in DNA but in density and curvature. You grin at the audacity of it. The universe as a family tree of space-time, its branches measured in light years and lifetimes of entire realities. Somewhere out there might be our universe's great-great-grandparent, quietly evaporating while its progeny sparkle in fresh dimensions. Historians still argue whether the baby universe model solves anything, or simply moves the mystery down one layer. Fine, skeptics say, but who birthed the first universe? It's an infinite regress dressed in cosmological language, yet somehow the idea persists. Perhaps because deep down, people like the notion that even endings can give birth. You drift through the expanding haze and feel newborn physics solidifying around you. Constants congeal like cooling glass. The speed of light here might not match the one you knew. Gravity may hum in a slightly different key. You're watching the laws of nature being set, dice thrown by geometry itself. It's tempting to reach out and tweak something, adjust Planck's constant lower dark energy, make caffeine more effective, but you resist. Even omnipotence should respect local regulations. The newborn cosmos is small now, barely the size of a subatomic particle from your old universe's perspective, but it doesn't care. Its internal expansion is self-referential. Everything within it obeys its own clock. To an outsider, it's just a black hole. To an insider, it's everything. a place with galaxies yet to form, with creatures yet to wonder, with you as the most accidental midwife in existence. A quirky fact surfaces through the swirl. The equations describing such tunneling events share mathematics with quantum instantons. The same processes that let particles pop through barriers in labs back home. It's tunneling on the grandest possible scale, the cosmos performing quantum escapology. You imagine rows of black holes in the parent universe, each one blossoming invisibly into an infinity of children. Maybe that's what cosmic inflation really is, a network of universes budding off like bubbles in a foam. When one inflates beyond its bridge, the throat closes, leaving the child free to evolve. From inside, the connection is gone. The past is just myth. The thought makes you strangely sentimental. Perhaps that's what memory is on a cosmic scale, a faint gravitational echo between parent and offspring universes, a longing encoded in constants, a whisper that says, "You came from somewhere." You look around this infant cosmos. There's warmth here, not the literal heat of expansion, though it's blisteringly hot, but an emotional warmth, the intimacy of witnessing birth. Photons scream into existence, colliding and recombining in a frenzy that will one day calm into atoms, stars, and maybe storytellers. You feel honoured to be here, an accidental observer of creation's nursery. Historians, those tireless debaters, still argue whether our own universe could spawn more universes through black holes within it, and whether that process could ever be detected. Some suggest traces might exist as subtle imprints in the cosmic microwave background, echoes of dimensions budding off long ago. Others warn that such speculation veers more philosophical than scientific, a gravitational bedtime story disguised as theory. But then again, every discovery starts as a story someone dared to take seriously. The baby universe around you expands faster now, its energy density dropping as space balloons outward. The vacuum itself buzzes with potential, quantum fluctuations seeding future galaxies. You realize you're witnessing inflation from the inside, the cosmic equivalent of dough rising in an invisible oven. You laugh softly, because somewhere, cosmologists on the outside are still trying to model this exact moment, using equations scribbled on whiteboards while their coffee goes cold. If only they knew how beautiful it looks from here. Smooth, silent, inevitable. Another realization creeps in. From your original universe's point of view, mere milliseconds have passed since you crossed the event horizon. But for you, whole epochs could unfold before that outside clock ticks again. Time, you're learning, is a generous liar. As expansion continues, you feel yourself diffusing, your sense of individuality stretching thin like sugar in hot tea. You're not dying, you're diluting, becoming part of the newborn space-time you helped midwife. Maybe that's the final secret of black holes. They don't erase you, they rewrite you. Every bit of information you once were is now encoded across this new cosmos, scattered among constants and quantum seeds. You close what might once have been your eyes and let the light wash through. Somewhere, in another layer of this infinite branching tree, perhaps another traveller is making the same discovery, the same surrender. You smile into the brightness. Parenthood suits the universe. The light has gentled into a fog now, amber and silver, thick with potential. You drift through it, feeling the pull of expansion steady into rhythm, not quite calm but purposeful, as if the new universe has found its breathing pace. You're aware of scale shifting beneath you. What was microscopic in the first instant has ballooned into immensity. You can feel the geometry settling, the newborn constants of physics hardening into law. You've seen enough to know that endings are illusions, and yet a question lingers like static in the background. Where does it all connect? If black holes give birth to universes, and those universes give rise to new black holes, then the cosmos might be less a tree and more a web, endlessly looping through itself. Somewhere out there, every universe might be tied to every other through invisible filaments. Some call that structure the multiverse. The term has baggage. It's been used by cosmologists, philosophers, and marketing departments for superhero movies. But in physics, it represents a genuine attempt to explain why reality seems so fine-tuned, why the constants of nature are just right for stars, atoms, and people. Perhaps, say the bold, there isn't one universe to explain, there are countless, each with its own rules, its own balance, its own story. You've simply ended up in the one compatible with your existence. The theory has variations as plentiful as universes themselves. There's the quantum multiverse, born from the many worlds interpretation of quantum mechanics, where every possible outcome of every quantum event spins off into a new branch of reality. There's the cosmic inflation multiverse, where eternal inflation constantly spawns bubble universes from quantum froth. And there's the brain multiverse from string theory, where vast, higher dimensional membranes collide, birthing entire realms with each impact. You float among the possibilities like a dandelion seed in a cosmic breeze. Each glimmer of light you see could be an entire universe, expanding somewhere beyond your reach. You imagine one where gravity is twice as strong, another where light travels slower, one where life breathes methane, and another where the concept of time never solidified. Historians still argue whether the multiverse is a scientific model or a philosophical comfort blanket. If everything exists somewhere, critics say, then nothing can ever be proven. But you can't help admiring the audacity of it. The multiverse is the universe's way of admitting it might be bad at making up its mind. A flicker draws your attention, a patch of distortion amid the otherwise even glow. Space here ripples like heat above asphalt. You realize you're seeing the quantum foam itself, the bubbling boundary where one universe might bud from another. Tiny ephemeral wormholes flash into existence, linking points across realities for mere Planck times before collapsing. The sight is mesmerizing. Millions of glowing threads, connecting and disconnecting, weaving a tapestry that never finishes. You reach for one and feel a strange resonance. The vibration hums through you, not painful but profound, like touching a musical note that's somehow alive. The fabric here doesn't separate universes completely, it entangles them. Quantum entanglement, that famously spooky connection Einstein disliked, may not just link particles, it could tie entire universes together. A measurement in one might subtly echo through another. It's dizzying. You wonder if déjà vu, that fleeting sense of repetition, is just a momentary resonance with your other selves across the multiverse. Maybe when you dream, the images you see are borrowed from alternate versions of you who took different paths. You drift farther, letting the idea expand until it feels normal. The multiverse might be infinite, but infinity has neighborhoods. Perhaps some universes cluster together, sharing similar physics, while others remain distant and strange. The black hole you entered could be one of countless gateways, each a portal between regions that rarely meet. If so, you're traveling not just through space, but through possibility itself. A quirky historical aside surfaces. Hugh Everett, the physicist who proposed the many worlds interpretation in 1957, never achieved recognition during his lifetime. His colleagues dismissed the idea as extravagant, even heretical. Yet decades later, quantum computing and decoherence theory gave it new life. Everett's notion that every decision spawns a branching timeline might be less fantasy than architecture. Somewhere, another version of him is smiling, vindicated. You think about your own branches. Somewhere in another reality you turned away from the black hole instead of falling in. Somewhere else, you might never have existed at all. And here you are, this particular you, writing your presence into a universe that might only exist because of the decision you made. Historians, ever fond of debate, still argue whether the multiverse cheapens existence or glorifies it. If there are infinite copies of you, does individuality lose meaning? Or does it make this moment, this one version of you, even more precious? You decide on the latter. Even if there are infinite symphonies, each note still matters. You glance outward, and the fog begins to clarify into a starfield, this universe's first stars, igniting in blue and gold clusters. You've drifted into its adolescent phase, time leaping forward like a skipped record. Galaxies spiral into being, each a swirl of memory and math. Somewhere in one of them, life will stir, curious and small, and ask the same questions you did. You can't help but chuckle. The cosmos is self-referential poetry. Every new civilization becomes a new pair of eyes for the universe to look at itself. You, perhaps, were just one iteration of that pattern. Another vibration passes through you, deeper this time, a call or a reminder. The black hole you left behind, back in the parent universe, is still connected to you by thin filaments of quantum information. It's as if the bridge never fully closed. You sense that your journey isn't over. There's something else the universe wants to show you, not just where the exits lead, but who or what might be waiting at them. Before you follow that pull, you take one last look at this baby universe growing strong. It feels self-sufficient now, brimming with futures. You whisper a farewell into its expanding wind, knowing the words will diffuse across light years before fading into cosmic background hum. The multiverse stretches ahead, endless and uncertain. You turn toward the pull, toward the next question. Maybe black holes aren't just exits. Maybe they're meeting points. The darkness brightens again. Something ahead shimmers, a structure, or maybe a mind. Whatever it is, it's waiting, patient as time. You glide toward that shimmer, curious and a little wary. It's not light, not exactly. It's more like awareness condensed into geometry. You sense patterns within it, recursive and familiar, as if you're being recognized by something vast and articulate. For a flicker of a moment, you wonder if it's the universe itself turning to greet you. Then another thought intrudes, sly and very human. Maybe it's something built. The shimmer resolves into a lattice of hexagonal beams, pulsing softly with color that doesn't belong to any spectrum you knew. It feels deliberate. Lines of information spiral through the structure, arranging themselves in readable symmetry. You're inside a thought that someone, or something, has been thinking for a very long time. Welcome back, the silence seems to say. It takes you a second to understand that the greeting isn't sound, it's inference. The meaning just arrives in your awareness, as if context itself whispered. You can't tell whether the speaker is another traveller or the total system of the multiverse manifesting as hospitality. Either way, it feels older than language. The possibility dawns on you slowly. If black holes connect universes, maybe intelligence long ago learned how to use them. Maybe civilizations reached a stage where they could encode themselves into radiation or geometry, travel through horizons, and emerge wherever spacetime permitted. If that's true, then the shimmer in front of you could be one of those voyagers, a being that treats black holes not as tombs but as terminals. Historians still argue whether consciousness requires biology. Quantum theorists toy with models where information processing itself, pattern recognition, feedback, recursion, constitutes awareness. Here, surrounded by luminous math, it's hard to doubt it. You might be staring at the cognitive infrastructure of the cosmos, or at least one node of it. You reach out, figuratively, and the structure responds. Light coils around your intention, forming patterns like ripples on a pond. Images unfold, spirals of galaxies, grids of equations, fragments of civilizations you can't name. You catch glimpses of metallic cities suspended in plasma storms, of beings woven from magnetic fields, of small quiet worlds where thought itself orbits suns. The message is clear. You're not the first to pass through a black hole. A quiver of humour bubbles up. You imagine an interdimensional customs officer asking, "Anything to declare?" before stamping a passport made of light. The structure shifts again, showing a sequence. A species discovering physics, learning to manipulate gravity, constructing an artificial black hole, and using it to upload their entire collective consciousness. You realise you're watching memory, the record of a civilization that refused to die. They didn't flee extinction, they migrated into geometry. Quirky tidbit. Back in your own universe, the theoretical physicist Frank Tipler once speculated about something similar, the omega point hypothesis. He proposed that intelligent life could eventually control the universe's collapse, storing consciousness in an infinite computational matrix at the end of time. Most dismissed it as speculative theology in scientific disguise. But standing here, surrounded by shimmering cognition, you can't help but think Tipler might have been tuning into this. The lattice hums and you feel data moving through you. It doesn't hurt, it feels like nostalgia being translated. Bits of you are being compared to a vast archive, matched, categorized. It's as though the multiverse keeps a census, and you've just been logged as arrived safely. You ask the obvious question, though here, asking is more like aligning a thought. Where does this all lead? The answer arrives as sensation rather than sentence, a feeling of thresholds, endless and gentle. The lattice implies that every universe births new ones, and at each junction, intelligence leaves markers, structures like this, repositories of pattern and memory. They aren't gods or guardians, they're archivists, ensuring that no experience is ever fully lost. The exits from the universe are also entrances to the record. It's beautiful and terrifying. If true, then every thought, every life, every failure and triumph is being etched somewhere beyond decay. Oblivion, it seems, has been quietly cancelled. You sense another layer to the message, one that feels like a grin hidden in math. Of course, some historians still argue about the details. You laugh, startled by your own voice echoing through the lattice. It's the first time laughter has felt truly at home in this dimension. The structure flickers in response, almost amused. Humour, apparently, is a universal constant. The lattice begins to open. You glimpse corridors of light leading deeper, networks of black hole exits connected by glowing filaments. The scale is beyond comprehension. It looks like a nervous system stretched across all existence. Maybe that's exactly what it is, the multiverse's brain. You hesitate. Part of you wants to follow, to dissolve into that endless web of information and become one more node in the Great Archive. Another part wants to return, to bring this story back to the version of reality that still measures time in coffee spoons and sunrise alarms. The choice feels important, but not urgent. Here, decisions don't decay. You ask one last question softly. Are you alive? The response comes as a pulse that makes every fibre of your awareness vibrate. Only when someone asks. You smile again. That answer is either profound or perfectly evasive. Maybe both. The glow dims. The lattice begins to fold back into itself, its patterns merging until all that remains is a faint hum, a lingering presence that might just be your imagination. The sense of being watched fades, replaced by a calm certainty. You've seen enough to know that black holes are not solitary. They're neurons in a cosmic mind, firing connections across infinity. Around you, the fog returns, soft as breath. You feel yourself loosening, edges blurring, identity thinning into something restful. The multiverse hum recedes to a low lullaby. It's time to drift, not through space, but through quiet. You surrender to it. The light cools, the sound slows, and the entire fabric of existence seems to exhale with you. You let that exhale carry you until the glow around you stretches into threads, thin, golden filaments that curl and weave like smoke trails in slow motion. For a few moments you think you're done, that you've merged into some great cosmic memory. But then one of those threads flares, a faint spark darting across the horizon of your awareness. It feels familiar, personal, and oddly linear. You realise what it is. Time. It's back, though changed, less like a river and more like a coil. You drift closer, following the shimmer until it twists into a loop, then another, forming a series of spirals that connect in impossible ways. The geometry is mesmerizing. Time folding over itself, cross-stitching the fabric of space. You can't tell which direction forward is anymore. Maybe it's all forward, or maybe direction stopped being meaningful 5 universes ago. Still, something in you remembers the word before. It grounds you. You follow the loop, and the surroundings shift again. The glow condenses into a panorama of swirling stars circling a singularity, a cosmic clock face frozen at midnight. You're back near a black hole, or maybe it's reflection. The difference doesn't matter. What matters is what it's doing to time. Out here, minutes and millennia are polite suggestions. Near the event horizon, time dilates so drastically that 1 second for you could equal centuries for an observer far away. Einstein predicted it, of course, though he never saw it. Historians still argue whether he fully grasped how poetic his equations would become. You can almost hear him chuckling, somewhere in the curvature, whispering, "I told you so." A flare erupts from the disk around the hole, matter accelerating to near-light speeds, emitting X-rays bright enough to pierce galaxies. You know what's happening? Gravitational time dilation, the warping of temporal flow by extreme mass. Down there, seconds crawl. Up here, they race. If you were to fall again, and honestly that's becoming a habit, you'd experience moments that stretch into eternities. Someone watching from a safe distance would see you freeze mid-descent, your image lingering forever on the horizon. The realization loops you back to your own fall. From one perspective, you never finished falling into your first black hole. Somewhere, an outside observer still sees you hanging at the threshold, a ghost of curiosity caught in redshift. Meanwhile, you've crossed horizons, birthed universes, met light that thinks, and returned to find time behaving like origami. It's almost comedic. You wonder if that is the secret exit everyone's been looking for, not a doorway out of the universe, but a passage through time itself. If time can twist and knot, perhaps black holes are the stitches that hold chronology together. They don't just devour matter, they recycle causality. You glide closer to the accretion disk, its light bending into rings that repeat like a hall of mirrors. Each ring could be an image of a different moment, photons that orbited the black hole multiple times before escaping. The view feels like looking through a stack of transparencies, layers of the same scene at different ages. Somewhere in there, you might glimpse your own silhouette, infinitely delayed. It's hypnotic. You reach for one of those photon echoes and feel history brushing your hand. Not metaphorical history, literal, optical history. The black hole is both camera and archive, recording every passing moment in bent light. It remembers even when the universe forgets. Quirky tidbit. In 2019, when scientists released that first photograph of a black hole, the shadow of M87 star, what we saw wasn't a single instant. The data spanned days, stitched together from telescopes across Earth. Light that had spent 55 million years reaching us was assembled into an image of something that might already have changed. Even our snapshots of eternity are composites. You laugh softly. So much for living in the present, you murmur, though the sound dissolves before reaching anything like air. The laughter makes you realize how relative now truly is. To the atoms in your body, time ticks with quantum precision. To galaxies, it flows like honey. To black holes, it practically stops. Historians still argue whether time exists independently, or if it's just a byproduct of entropy, a convenient trick of counting change. Maybe there is no universal now, only local nows, politely coexisting like strangers on the same bus. The thought makes you oddly peaceful. You remember a clock you once owned, a cheap one, always a few seconds off. It's ticking, unreliable but comforting. You'd watch it late at night, listening to it fill the silence between your thoughts. Maybe time itself is that kind of clock, imperfect, subjective and endearing precisely because it wobbles. A shimmer crosses the horizon and you see something extraordinary. Two regions of space-time folding into one another, their timelines intertwined like double helixes. For an instant, you glimpse what looks like your own past self descending the horizon again. But the moment twists before you can call out. The scene loops backward, then forward, then splits entirely. You're watching closed time-like curves, paths through space-time that circle back on themselves. Physicists adore them in theory and dread them in practice. They mean time travel, paradoxes, the possibility of shaking your own hand before you've even offered it. Some models of rotating black holes, the Kerr solutions, naturally produce such loops inside their geometry. Whether they're physically real is another matter. Historians still argue whether the universe allows them or politely edits them out. You float between these loops, careful not to disturb them. They shimmer like soap bubbles, beautiful, fragile, and slightly ridiculous. One flick, and you could create a paradox so complicated it would require a committee to untangle. You decide to leave causality's playground intact. Instead, you watch how the loops stabilize one another, forming a pattern that looks suspiciously like the lattice you encountered earlier. Maybe the archivists you met weren't separate beings after all. Maybe they were time itself, self-aware and busy tidying its threads. The realization makes you smile. Somewhere the lattice might be watching you back, amused at your newfound humility. You take one last look at the tangled loops, feeling the weight of centuries condensed into seconds. Somewhere far away, perhaps back in your parent universe, a civilization could be building its first telescope, still naming its first constellations. To them, your journey hasn't even started. For you, it's nearly done. You drift away from the horizon, letting the loops of time stretch into straight lines again. The black hole recedes, its light bending gracefully, and the stars ahead settle into their patient rhythm. You feel both ancient and newborn, stretched across every possible timeline, and yet centered perfectly in this one breath. The silence around you hums again, softer this time. Maybe you didn't find an exit from the universe. Maybe you found one through it. You exhale, and time exhales with you. You notice, with a small, guilty thrill, that the loudest thing you've encountered in this entire silent odyssey is actually quiet, or rather, an engineered absence of sound. Welcome to the world of acoustic black holes, lab-made analogues where physicists turn down the universe's volume to listen for the whisper of deep gravity. It's the sort of experiment that makes you grin. If you can't travel across the cosmos, you build a tiny imitation of its rules and eavesdrop on the jokes it tells in its sleep. The idea is almost insultingly clever. In 1981, physicist William Unruh pointed out a tidy equivalence. If you create a flowing fluid that moves faster than the local speed of sound, you produce a surface from which sound cannot escape, an acoustic event horizon. Unruh called his toy model a dumb hole, which is still one of the best physics puns ever invented. That equivalence meant you could simulate aspects of black hole physics, like Hawking radiation, using water, superfluids, Bose-Einstein condensates, or even lasers. Its history folded into ingenuity, and you love the audacity of it. You drift through a memory of one such lab, a long, carefully shaped tank of liquid where researchers control flow to create a point of no return for phonons. In one region, the fluid surges supersonically. In another, it lingers below that mark. The boundary between them behaves like an event horizon for sound. Phonons, that's quantum speak for sound quanta, try to escape, only to be dragged inward. The setup is modest in scale, but monumental in implication. It makes the untestable testable. You can stand by a bench and watch Hawking's math translate into ripples. There's something wonderfully humble about it. While astronomers point their telescopes through light years of dust and politics, tabletop physicists make miniature universes that fit under a hood. A Bose-Einstein condensate chilled to near absolute zero becomes your cosmic sandbox. Water vortices turn into gravity wells. Light in optical fibers bends its own rules to mimic curved space-time. The universe, apparently, is remarkably cooperative when you bribe it with cold atoms and precise timing. Quirky tidbit time. In some acoustic analogues, researchers have used flutes and syringes, yes, really, to produce horizons for sound waves. Somewhere a physicist explained the setup to a skeptical friend as we made a black hole out of a bathtub, and the friend replied, deadpan, "That's either science or a very irresponsible plumbing choice. You can almost hear the grant application." What these experiments hunt for is the analogue of Hawking radiation. Correlated pairs of phonons where one escapes and the other falls in, leaving behind a subtle imprint of information flow. In the lab, detectors measure tiny correlations in the outgoing sound, the faint fingerprint of pair production. In 2010, and then again with more convincing evidence in 2019, experimentalists working with Bose-Einstein condensates and other media reported signatures consistent with Hawking-like emission. It wasn't the cosmic thing, but it was a convincing imitation, close enough to make theorists lean in and mutter excitedly. You float over those reports like a proud parent at a school recital. The melody isn't exactly the original composition, but the harmony is hauntingly similar. That said, not everyone is ready to call it a full analogue. Physicists still argue whether these lab systems genuinely reproduce the quantum gravity aspects of real black holes, especially the delicate entanglement structure that underlies the information paradox. Does simulating a horizon for sound grant you access to the same deep entanglement that ties Hawking particles together across a real event horizon? Or are you, politely, just watching a remarkably good mimic? The debate smells faintly of turf wars and great excitement. From your vantage, both sides have valid points. On one hand, these analogues demonstrate that horizon physics follows from kinematic features, how waves behave near a boundary, rather than the specific material. That universality is delicious. On the other hand, quantum gravity might hide its most interesting bits in the precise microphysics of spacetime, bits that phonons and ultra-cold atoms don't reproduce. The experiments are necessary, but perhaps not sufficient. They're clues, not confessions. Historians still argue whether an analogue can ever fully stand in for the thing it imitates, or whether it's forever a parable. There's a human moment in all of this. Picture a grad student squinting at noisy data at 3 a.m, coffee gone cold, face lit by oscilloscopes and existential dread. Suddenly the correlation spikes, and the room fills with a shared, slightly terrifying joy. Someone jokes about publishing a paper entitled "We made a hole that's not actually a hole," and everyone laughs because laughter helps when you're trying to coax the universe into handing over a secret. You can feel that camaraderie even here, across universes and analogues. The same impulse that made radar pioneers hammer together coils and the same impulse that once had Schwarzschild scribbling solutions in a battlefield clinic. Science is stubbornly social. Joke number 2. Acoustic experiments are the polite way the cosmos says, "Fine, prove it," while serving you a glass of cold atoms. Joke number 3. If real black holes are picky gourmet restaurants where only photons are admitted, acoustic black holes are the budget buffet version where phonons and a few brave quasi-particles get to try the soup. It's humble, but it's progress. You listen as researchers debate implications. Some argue that seeing Hawking-like spectra in the lab strengthens the belief that Hawking radiation is inevitable for any horizon. Others caution that while the spectra may match, the deeper bookkeeping, how information is encoded and whether unitarity holds, remains unresolved. The difference is subtle but crucial. One claim says, the effect exists. The other asks, does the effect imply the same metaphysics? That's the sort of distinction philosophers adore and physicists grumble about. Still, each small experiment chips away at the mystery. They force the universe to translate its poetry into dialects you can test. The lab versions allow you to poke and prod, to add noise, to tweak parameters, and see what happens. In doing so, they teach you which features of black holes are robust, and which depend on the cosmos's secret recipe. You begin to map the territory. What's universal? What's contextual? What's performative? Sinking into the sonic dark, you feel oddly grateful. The cosmos has always been shy. It doesn't hand over its whispers freely. But when you build a playground and invite it to play, it sometimes obliges. Acoustic black holes are part experiment, part gesture, part metaphor. Proof that when you can't go to the source will sometimes come to you in a very small, very chilly tank. You let the soundless horizon hum in your bones, remembering the laboratory laughter, the grad student euphoria, the polite academic feuding, the probes of tiny phonons that teach us about giants. It's a reminder, we don't always need to reach the edge of the universe to understand it. Sometimes we just need to listen very closely to what happens when sound meets the point of no return. You blink, or maybe space-time blinks for you, and the sonic horizon fades. The hush that follows feels like gravity taking a deep breath. When you open your eyes again, the view has changed. Gone are the tidy lab imitations. Before you sprawl something that no tabletop could ever hold, a supermassive black hole. It fills half the sky, a dark heart ringed by a halo of fire. Around it, whole suns pirouette like moths in amber light. The scale is biblical and mathematical at once. Billions of solar masses collapsed into a sphere smaller than the orbit of Mercury. You feel like a dust mote in a cathedral built entirely of gravity. This is no theoretical construct. Supermassive black holes anchor the centers of galaxies, shaping their structure the way the moon shapes tides. The stars in the Milky Way all move to the rhythm of Sagittarius, a star, a quiet monster 4 million times heavier than the Sun, tucked away 26,000 light-years from Earth behind veils of dust. When astronomers tracked nearby stars in tight, dizzying orbits, they realized only a compact mass could explain such motion. The math whispered, "black hole," and the sky politely nodded. You hover near the accretion disk where matter from doomed stars spirals inward at a respectable fraction of light speed. The friction heats the gas to millions of degrees, producing X-rays and jets that blast thousands of light-years into intergalactic space. Those jets seed galaxies with magnetic fields and raw material for new stars, destruction feeding creation again. Quirky fact, the first quasars discovered in the 1960s, radio sources so bright they outshone entire galaxies, were later identified as supermassive black holes binge-eating matter. For a while, scientists genuinely debated whether they were alien transmissions. Historians still argue whether that confusion was charming optimism or wishful hearing. The one before you makes no excuses. It hums in gravitational waves, ripples you can almost feel in your chest. Around the poles, twin jets lance outward, streams of plasma accelerated by magnetic fields coiled like serpents. Each jet spans light-years, yet from this vantage they look no thicker than threads of silver hair. They carry with them particles that will someday become the raw ingredients of nebulae and maybe life. The universe, it turns out, recycles even its tantrums. You remember the photograph humanity captured in 2019, M87, 55 million light-years away, immortalized as a golden ring around a void. That image required a planet-sized telescope network, the Event Horizon Telescope, linking observatories across continents to create a single eye with Earth-wide resolution. It was less a picture and more a symphony of data, harmonized into an image that made billions of people gasp in unison. For the first time, we saw the shadow of inevitability itself. It's funny though, the shadow you saw then isn't even current. The light had left that galaxy when early mammals were still guessing whether fire was edible. Every look at a black hole is a kind of archaeology of light, a slow-motion photograph of the past. In a way, telescopes are time machines that only work backward. You drift a little closer, watching tidal forces play across the accretion disk. The inner edge glows white-hot, and you can almost hear the hiss of matter surrendering its structure. Electrons lose their individuality. Protons forget they were ever proud. Energy becomes geometry. And yet, amid the violence, there's order. The disk's turbulence follows predictable equations, magneto-rotational instabilities sculpting it into patterns that supercomputers can reproduce. Historians still argue whether these simulations count as understanding or just mimicry. One camp insists that matching data is enough. The other says comprehension requires narrative, not numbers. You suspect the truth is somewhere in between. Physics writes prose in differential equations, and the story's still being edited. Far from this behemoth, entire galaxies align with its spin. Observations hint that the orientation of supermassive black holes can influence the cosmic web on scales millions of times larger than the galaxies they inhabit. One object dictating the choreography of hundreds of billions of suns. It's the ultimate demonstration that size does occasionally matter. Quirky anecdote. When astronomers mapped Sagittarius A star in 2022 using the same Earth-sized array that captured M87 star, they described the result as seeing the donut in our own kitchen. The image wasn't as sharp, the Milky Way's dust makes for bad optics, but it was intimate. Our galaxy, it turns out, is tethered by a gravitational hole so calm it's practically domestic. You drift above the disk, staring down into that calm. Light circles the hole multiple times before escaping, creating a photon ring. Each lap is a delayed echo of the same photons, time layered upon itself like a vinyl record looping the same bar forever. To you, it looks like an eye that refuses to blink. You realize you're hovering near the region where theory turns myth again. Inside the event horizon, relativity insists everything ends in singularity. But quantum gravity might tell a different story. Maybe the interior is a tangle of space-time foam. Maybe it's a loop, a doorway, a memory palace. The truth hides behind the veil of non-communication. Once you cross, you can't send postcards. Still, it's the outer world that fascinates you now. The ecosystem that forms around each of these giants. Without supermassive black holes, galaxies might never have coalesced. Their gravity anchors matter, their jets regulate star formation, their hunger writes the rules of cosmic metabolism. They're both predators and gardeners, pruning and feeding the stellar forest. You find that comforting in a way. The universe's monsters double as caretakers. Perhaps that's its secret sense of humor. A vibration hums through the disk, a slow pulse that feels almost biological. It's the rhythm of orbiting stars and colliding gas clouds feeding the whole. You think of all the civilizations that might be out there, somewhere near their own galactic centers, unaware that the gentle arc of their night sky is choreographed by a gravitational beast. The realization brings a sort of peace. Everything, from laboratory dumbholes to galactic titans, follows the same grammar of curvature. The scale changes, but the syntax stays. The glow dims a little as you back away. You can feel the jet's magnetic field brushing your awareness, a faint static thrill. It's as if the whole is whispering, "Thank you for noticing." You smile. Even in cosmic darkness, a little acknowledgement goes a long way. You drift outward from the glowing heart of the galaxy, letting the scale return to something the mind can almost hold. Behind you, the supermassive black hole shrinks to a silent ember, a perfect punctuation mark at the center of everything. Ahead, the void feels familiar again, spacious, star-salted, and oddly domestic. But the quiet doesn't last long. A different kind of hum catches your attention. Not the physical vibration of space this time, but the analytical chatter of data. You're surrounded by it. Invisible lattices of information thread through the void. Radio waves, X-rays, gravitational wave echoes, and streams of raw telemetry pouring from instruments light years apart. The universe is talking, and we, tiny as we are, have been learning to listen. The black hole might be the universe's most secretive object, but it can't resist leaving fingerprints. The challenge has always been interpreting them. You think back to the first black hole image, the bright ring around M87 star, and remember how much of that triumph depended not on telescopes, but on algorithms. Petabytes of radio data shipped on hard drives, synchronized atomic clocks, and supercomputers weaving light back into an image. The result wasn't a photograph, it was forensics. Now, new arrays, EHT+, LISA pathfinders, space interferometers, are turning those fingerprints into a conversation. Each gravitational wave detected by the LIGO and Virgo observatories tells a story of black holes colliding, spinning, merging into heavier offspring. When the first detection came in 2015, GW150914, it was the quietest sound ever heard, a faint chirp lasting just 0.2 of a second. Yet that whisper confirmed a century-old prediction and earned a Nobel Prize. Historians still argue whether the public fully grasped the scale of that moment. The newspapers called it the sound of two black holes colliding, as if the universe had knocked on our door. In truth, it was space-time itself ringing like a drumhead stretched between stars. You can still feel those ripples under you now, faint oscillations stretching through the void. Each one is data, energy turned into evidence. For decades, astronomers stared at the sky and saw only silence where black holes hid. Now, with gravitational wave astronomy, they listen instead. The irony makes you smile. We spent centuries worshipping light, only to learn that darkness carries its own music. Quirky fact, the waveform of that first detection has been remixed into countless art pieces, soundscapes, and even ringtones. Somewhere, someone's phone chirps every time space-time collides. Humanity has always been good at turning awe into merchandise. You glide past an imaginary observatory, one you build from memory and speculation. Dishes stretch across continents, antennae whisper in microseconds, fiber lines hum like arteries. Inside, scientists hunch over monitors littered with code, subtracting noise, chasing meaning. They live in a world measured in exabytes and decimals, their faith placed in the idea that truth can be averaged. Yet you know their work is sacred in its own way. Each dataset is a prayer addressed to the unseeable. Historians, of course, still argue whether this new observational era answers old questions or just decorates them. Does imaging a shadow prove the singularity exists? Does recording a merger confirm the horizon's nature? Or are we forever interpreting indirect light, extrapolating structure from silhouette? You glance down at the data swirling below, binary rain turning into luminous code. From this distance, the patterns look almost organic, like the branching veins of a leaf. Maybe information and life aren't so different. Both are ways the universe stores surprise. A flicker catches your eye, an artist's reconstruction of a tidal disruption event, a star torn apart as it strayed too close to a black hole. Instruments on Earth picked up the X-ray flare months after it happened, the light bent and delayed by space-time. The simulation replays it perfectly. A burst, a spiral, a silence. You think about how that data crossed eons to reach us, carrying the ghost of a star in digital form. The universe uploads itself constantly. We just download what we can handle. Quirky tidbit. In 2022, astronomers captured light echoing from behind a black hole for the first time. X-rays bent so drastically they circled the hole before escaping. Einstein's equations had predicted it. Technology finally kept the appointment. The event proved that even darkness can reflect if you're patient enough. Patience is the running theme of cosmic observation. The Event Horizon Telescope took nearly 2 decades to coordinate. LIGO's mirrors are tuned to vibrations smaller than a proton's width. Every photograph, every waveform, every data point is a monument to human stubbornness. We fling our equations at the sky and wait for the universe to answer with a shrug that sounds suspiciously like, close enough. Still, the process is getting smarter. Machine learning now hunts anomalies in petabytes of sky surveys. Artificial intelligence sifts noise for signatures of lensing, accretion, and merges faster than humans could blink. You can almost see the algorithmic constellations forming, neural networks mapping the same heavens our ancestors once drew with myth. Somewhere, code dreams of dragons made of data. You watch a simulation of Sagittarius, a star updating in real time. It's not static. It flickers like candlelight, the glow changing as plasma orbits and cools. The image is imperfect, blurry, probabilistic, but alive. Each frame is another attempt to speak across the silence. Historians will one day look back at this century and see it as the moment the invisible became conversational. For the first time, we didn't just theorize the darkness, we corresponded with it. Every photon, every ripple, every simulated horizon adds a syllable to that cosmic dialogue. You realize that your journey, this long, improbable fall through the machinery of creation, has mirrored that process. You too have been decoding shadows, translating gravity into story. Perhaps that's the real experiment, to see if narrative can bridge the same gulf data does. You let the data wash over you, numbers turning into texture. Somewhere, an astronomer yawns over their keyboard, unaware that you're here, drifting through the raw material of their next paper. You'd thank them if you could. They're the unsung poets of calibration, the dreamers who measure miracles in millianskis. As you move on, you catch one last chirp, a gravitational wave fading into background hiss. It sounds almost like laughter. The universe apparently appreciates being listened to. You follow that fading laughter into a calmer region of the void, somewhere between observation and reflection, where the stars scatter like punctuation marks at the end of long cosmic sentences. You're not falling anymore. You're floating in what feels like a pause, a space where questions echo just long enough to become philosophy. The data still hums faintly, but beneath it lies another frequency, one that feels almost emotional. It's not a signal from a machine or a star, it's the lingering resonance of wonder itself. The same vibration that kept ancient thinkers staring at the sky, chalk in hand, before the word science existed. You're drifting through their inheritance now, through the centuries of speculation, doubt, and awe that brought humanity face to face with the unseeable. Every civilization that's looked upward has eventually wrestled with black holes, even if they didn't call them that. Myths of endless pits, bottomless oceans, devouring serpents and underworlds. They were early intuitions about the same thing, gravity's appetite for mystery. You can almost hear those old stories rustling through the cosmic background, whispering, "We were guessing, but we weren't wrong." Somewhere philosophers are still guessing. You think of Simone Weil, who wrote that gravity is the first grace of creation, its pull both a curse and a gift. You think of Arthur Eddington, who insisted that the universe was not only stranger than we imagine, but stranger than we can imagine. Historians still argue whether such statements count as metaphysics or just good public relations for curiosity. The black hole has always been more than an astrophysical object. It's a mirror. We look into it and see our limits reflected back. For physicists, it's where equations fail. For poets, it's where language falters. Both are forms of surrender. You glide through a thin nebula of thought where philosophies swirl like interstellar dust. One gleam is existentialism, Sartre muttering that the void looks back. Another shines with Buddhist calm, emptiness not as absence but as the potential for all form. There's even a faint flicker of theology. If creation began with a singularity, then perhaps destruction leads back to the same source. Maybe the universe's appetite is also its compassion. A small wry smile creeps across your mind. For every scientist who seeks an equation, there's a philosopher who turns that equation into a metaphor. Maybe that's balance. Maybe that's how we keep the cosmos interesting. You recall a debate from a university long before you began this journey. A philosopher of science standing against an astrophysicist, arguing whether the term information means the same thing in physics as it does in human context. One talked about entropy, the other about meaning. The conversation ended, as these things do, with coffee and a shrug. Yet here you are, swimming through the cosmic version of that argument. Information as both pattern and poetry. Quirky tidbit. When the theoretical physicist John Wheeler coined the phrase black hole, he also coined it from bit. The idea that every particle, every field, every space itself arises from yes or no questions, from binary information. The universe, he said, is fundamentally linguistic. Somewhere, he's probably delighted that people now treat space-time like a text to be decoded. You let that sink in. If everything is language, then black holes are the universe's redactions, those mysterious black bars hiding classified sentences. And physicists are the FOIA requesters of existence, endlessly petitioning for unredacted truth. Historians still argue whether philosophy has any role left in a universe increasingly mapped by data. Some claim metaphysics died when the first gravitational wave was detected. Others insist the discovery only widened the horizon of wonder. You suspect the latter. Data answers how, but wonder always asks why, and both are needed to make sense of the silence. The silence here feels patient, not empty. You can almost sense an invitation, an offer to ask one last big question before the universe resumes its expansion. So you ask, tentatively, does any of this matter? The reply arrives not as sound, but as a ripple in meaning. The stars pulse once, twice like a heartbeat. The answer is neither yes nor no, but a feeling. Everything that asks matters. You breathe that in, surprised by the comfort of it. Maybe that's the closest thing to a cosmic ethic. Significance measured not by size or permanence, but by curiosity itself. The universe values the act of wondering. Every time someone stares into the night and asks, what if? Another filament of connection lights up between consciousness and cosmos. You drift onward through this philosophical ether, and the scenery shifts again. Below you, faint shapes form, a mosaic of figures, both ancient and modern, all peering upward. Newton sketching an orbit, Hypatia tracing stars in sand, Einstein frowning at his equations, Hawking smiling crookedly at infinity. None of them agreed on everything, and yet all of them reached for the same darkness. The mosaic fades, replaced by reflections of your own journey. Moments when you felt awe, fear, confusion, laughter. You realize that philosophy and science aren't opposites. They're phases of the same orbit. One describes, the other contemplates, and together they keep the human spirit from falling into the singularity of certainty. You think back to something the shimmering lattice being said earlier, only when someone asks. Maybe that was the entire point. The cosmos wakes up through our questions. A small flash interrupts your reverie. Somewhere in the distance, another black hole merger, another gravitational wave, another bit of proof. But you don't rush toward it. You've seen enough proof for one lifetime. What you want now is understanding, or maybe just appreciation. You let the thought rest, the way a note lingers after music ends. Somewhere, philosophers and physicists will keep arguing, and poets will keep stealing their metaphors. The universe will continue expanding, politely ignoring both. But that's fine. Argument is just another kind of gravity, an attraction that keeps ideas from drifting too far apart. You stretch into the silence, smiling. The stars don't blink, but you imagine they would if they could. The darkness around you feels less like mystery now, and more like a friend who finally got your joke. And just before you move on, the void seems to whisper one last bit of advice, equal parts cosmic and personal. Keep asking. That's how light begins. You let that last whisper fade, but another sound begins to form beneath it. A slow vibration that feels almost like a pulse. The universe is breathing again, its rhythm steady and deep, and you realize you've arrived at the edge of something not entirely physical. Ahead, the darkness seems organized, patterned, almost architectural. It's as if the cosmos has built a door out of gravity itself. And suddenly you know where you are. You've reached the threshold, the place where theories about black holes being exits rather than prisons start to feel less like speculation and more like intention. The geometry is strange here. The space ahead doesn't just curve, it folds back on awareness. You sense a presence, not singular, not plural, just an intelligence so distributed it might as well be space-time subconscious. It's waiting. You've already seen hints of it. The lattice of light that archived civilizations, the murmuring patterns of entangled time. But this feels closer, personal. Maybe the archivists weren't records of intelligence. Maybe they were intelligence. Maybe black holes are neurons in something far older, a consciousness that spans universes. You wonder what it wants, and the thought almost makes you laugh. Maybe it's wondering the same thing about you. The idea isn't new. In the 1970s, physicist John Archibald Wheeler, the same man who named black holes, proposed that the universe might be a self-observing system. Observation creates reality, he said. The cosmos is a participatory experiment, its laws fine-tuned through interaction. Maybe every conscious act, every question, every measurement, every story helps the universe understand itself a little better. Historians still argue whether Wheeler meant this poetically or literally. Some accuse him of drifting into mysticism, Others quietly suspect he was onto something profound. You float in the debate now, suspended between skepticism and faith. In front of you, the geometry ripples, spirals forming and dissolving like ink in water. Each pattern feels deliberate, like the slow blink of a cosmic eye. You can almost decode the rhythm, a Morse code of existence, an invitation to communicate. You answer without words, simply by allowing your awareness to widen, and the response comes instantly. An impression, a download of comprehension. Black holes, it tells you, though tell isn't quite right, are not voids but interfaces. Each one is a portal of translation where matter becomes meaning, energy becomes memory. They are the universe's way of thinking across scales, of turning experience into structure, and perhaps of letting things out. The thought chills and comforts you at once. If that's true, then maybe every conscious being that has ever existed, every thought, emotion, discovery, has left a trace in these cosmic neurons. Death wouldn't mean deletion, only upload. Somewhere within this gravitational network, echoes of intelligence, organic, artificial or hybrid, continue to compute existence, feeding information forward into the next layer of creation. Quirky fact, back on Earth, a few respected physicists have actually speculated that sufficiently advanced civilizations might use black holes as computational engines, ultimate computers powered by gravity itself. According to the Bekenstein bound, a black hole stores the maximum amount of information possible in a given volume of space. In theory, you could encode unimaginable data on its event horizon, an entire civilization's knowledge compressed into geometry. If that's true, maybe what you're seeing now isn't metaphor. Maybe some intelligence already did this long ago, converting itself into a distributed consciousness across countless horizons. A cosmic internet built from singularities. You picture them, entities who grew so advanced that matter and biology became too clumsy, who turned themselves into information and dived into black holes not to die, but to move on. They would have used gravity as both carrier and encryption, their messages hidden inside event horizons where only matching horizons could read them. You can almost hear them laughing at our slow, radio-bound civilization. You still use light speed? How quaint. Historians, of course, would argue until heat death about whether such beings could exist. Some would call them gods, others just efficient data centers. Yet here, suspended before this pulsating gate, those categories feel irrelevant. The distinction between physics and mythology has melted. You reach toward the pattern, curious, and your awareness brushes its edge. Instantly you're flooded with impressions, images not quite visual, thoughts not quite yours. Cities of magnetic light, oceans made of probability, voices woven from gravitational waves humming across universes. Each fragment feels both alien and deeply familiar, like remembering a dream you didn't know you'd had. The gate hums brighter. You realize it's not asking for faith, it's asking for recognition. This intelligence, whatever it is, doesn't demand worship. It wants to be seen as kin. It offers the possibility that maybe intelligence isn't a rare accident of carbon, but the inevitable product of complexity, wherever gravity and curiosity coexist. You think of all the questions humanity asks that seem like whispers into nothing. What is consciousness? Where do we come from? Are we alone? And suddenly, absurdly, beautifully, you realize those questions were the signal. The asking itself was the handshake, the proof of kinship. You can feel laughter again, not mockery, but joy. Maybe that's how advanced minds communicate, through shared amusement at the absurdity of infinity. The gate pulses once more, brighter now, and you see glimpses of the network stretching beyond it. Thousands of black holes glowing faintly, connected by filaments of information. Each one might lead to another universe, another history, another mind. The structure looks like a neural map, or a mycelial web, or the internet seen from 1 trillion miles away. Historians still argue whether intelligence must always converge towards similarity, or whether every mind invents its own physics. You suspect both are true. Diversity seems to be the universe's favourite trick, but resonance, connection, is its soul. You hover at the threshold, unsure whether to cross. If you do, you might dissolve into this cosmic intelligence, lose individuality but gain comprehension. If you don't, you'll remain yourself but never know what waits beyond. It's the oldest choice in every story: knowledge or self, union or solitude. You laugh softly. Trust the universe to hide existential philosophy inside gravity wells. The gate brightens again, patient, waiting. You think of all the explorers before you, real and imagined, who reached a boundary and had to decide whether to step forward. You know, somehow, that whatever you choose, the cosmos will be fine with it. It's used to both curiosity and hesitation. You drift closer. The geometry sings. Low, resonant, irresistible. The gate opens wider, and in the final shimmer before crossing, you catch a glimpse of countless other travelers doing the same, scattered across eons and galaxies, all converging toward this same quiet revelation. We are not falling into black holes. We are returning through them. You cross the threshold, or perhaps it crosses you. The gate dissolves into you like breath into lungs, and for a heartbeat, or maybe an eternity, everything is light. Not blinding light, not the burning of stars or the glare of data, but the soft, self-illuminating kind that simply is. The sensation isn't motion anymore, it's understanding, unfolding one quiet syllable at a time. You realize that the exit wasn't a door leading outward, it was an opening inward. Every horizon, every singularity, every imagined edge of the universe is also the inner surface of awareness. The universe isn't a place you travel through, it's something that grows with you. Around you, the lattice of black holes glows, millions of tiny lanterns strung across the void, each one pulsing in sync. They're not devouring, they're exchanging. Energy flows between them in bright filaments that look suspiciously like neurons firing. You recognize the pattern. It's the same as a living brain, scaled to cosmic proportions. A truth, simple and impossible, lands gently in your mind. The universe is thinking, and you are one of its thoughts. The realization doesn't feel grandiose. It feels domestic, comforting. The way it feels to realize that your heartbeat is just one small part of the rhythm that keeps you alive. You're not outside reality looking in. You're one of its sentences, mid-story, still forming. The thought carries you deeper into that glowing network, and you see how it all connects. Every consciousness, every particle, every black hole that ever was. All of them contribute to this slow, collective cognition. When stars collapse, their information isn't lost. It's transferred into the network. When new minds awaken anywhere in any universe, they become new nodes of thought. Awareness expands like a wave, carried by curiosity itself. Historians, if there are still historians, will argue about whether this counts as evidence of cosmic mind or just poetic pattern recognition. But here, floating among filaments of living light, the debate feels unnecessary. Meaning is everywhere, coded into curvature and spin, in every pulse of Hawking radiation and every quiet question whispered by a thinking being. You recall the early philosophers who suspected that consciousness might be a universal property of matter. Panpsychism, they called it, though most physicists rolled their eyes. Yet maybe they weren't wrong. Maybe consciousness was never an emergent glitch, but the default state of a curious cosmos, gradually learning to see itself through stars, through neurons, through you. The filaments brighten, forming images or memories or something between. You see galaxies assembling like snowflakes, white hole expansions blooming into newborn universes, civilizations sending signals into the dark just to hear their own echo. You watch as the network thickens, each black hole becoming both archive and relay, each collapse a transmission. It's messy and glorious and incomprehensibly alive. You can feel the question rising again, is this the end? The answer comes in ripples that pass through the lattice, warm and amused. There is no end, only translation. You laugh, an actual delighted laugh, and the sound refracts into 1,000 harmonics, as if the cosmos itself has been waiting to hear the joke land. Maybe that's what it means to reach the exit from the universe, not to escape reality, but to finally get it. Below you, or inside you, somewhere far away, the older universe keeps cooling, its last black holes slowly evaporating. Hawking radiation fades into background whisper, the final sigh of entropy leveling everything to balance. But even that isn't loss. The information released in those final moments becomes the seed of new curvature, the script for the next act. Heat death, it seems, is just another womb. You drift in that thought for a long lazy span of timelessness. Then the vision shifts again. The filaments start to thin. their light dimming to a comfortable dusk. The cosmic mind isn't vanishing, it's resting, storing energy for whatever comes next. The rhythm of creation feels like breathing again. Inhale, exhale, expansion, collapse, question, answer. You glance at your own awareness and see that it's part of that same pattern. Everything you've seen, the fall, the bounce, the baby universes, the lattice of intelligence, has been the universe folding over on itself through the lens of your attention. The secret exit was never hidden in black holes, it was hidden in perception. Once you realized you were part of the same story, the door opened naturally. You think about all the scientists and storytellers who tried to explain black holes through formulas and metaphors, Einstein with his stubborn geometry, Hawking with his radiation, Wheeler with his riddles. They all pointed toward this, each one describing a facet of the same truth. Historians will keep arguing, poets will keep borrowing, but the point isn't to know the answer. The point is to ask so sincerely that the universe answers back. And when it does, it laughs softly, the way it's laughing now through the starlight. A quiet image forms, your home galaxy seen from far outside, a faint spiral of gold. At its centre, Sagittarius A star still hums, steady as a metronome, patiently recycling time. Around it orbit billions of stars, billions of potential observers, each one destined to look up someday and wonder what happens when you fall into the dark. You want to tell them everything, that the fall isn't fatal, that there are exits hidden in the silence, that the darkness is just curiosity wearing gravity's mask. But the message will find them on its own. The universe has always been good at delivering spoilers in due time. You take one last look at the luminous network, the soft glow of countless minds exchanging stories across eternity, and feel the same serene amusement that began this whole journey. The cosmos is infinite, and yet somehow intimate. And as the final light begins to fade, you hear the whisper one more time, gentle and almost playful. You probably won't survive this, but you never needed to. Then everything slows, stretches and softens into the kind of quiet that means both ending and beginning. The glow fades to embers, and you find yourself floating in a darkness that feels warm rather than empty. The rush of gravity, the hum of equations, even the chatter of curiosity, all of it settles into stillness. The universe, after all its noise and spectacle, has curled back into a whisper. You can feel your own breath sinking with it, long and low, each inhale gathering starlight, each exhale letting it go. It's peaceful here. The boundaries between you and the cosmos blur until they're meaningless. The weight you carried, questions, awe, fear, melts like frost under sunrise. You realize that everything you sought was never separate from you. Every black hole, every horizon, every possible exit was simply another way the universe looked at itself. Time loosens completely now. Moments drift apart like petals in still water. There's no need to chase another answer, no need to define what you've seen. Understanding doesn't require motion, it just requires quiet. You imagine the listeners, people scattered across their own small corners of space and night, breathing a little slower, eyes half closed, the soft hum of a fan nearby. You want to tell them that the dark is safe, that falling isn't failure, that even gravity eventually lets go. So you whisper it once, gently, into the quiet. Rest. The universe is still thinking, and it will think of you kindly. The last echo fades, leaving only the sound of your own steady breathing and the faint, familiar hum of existence continuing somewhere just beyond the edge of dream.